Hello, everyone. Good morning. Okay. So I think we can start. Just a second. So how was the contest, first of all? Is it good, bad, not so good? Hmm. Okay, I see two of them are marked as easy. Third one was, I'll say, thoda sa tricky. Actually, I'll say ki the wording of the question is should be a little bit more descriptive. Okay, it took me a little bit while to figure out ki what it is trying to do or what's the solution is. Okay. So question में I guess understanding में problem. If I explain the question, I guess most of you will be able to do. Otherwise, it's like a brute force solution. It's there is nothing like I thought कि there was something like गलती से आ गया question, but there is nothing uh, like what I'll say is that you have not that you don't know, right? So it's just that थोड़ा सा wording could have been better to understand that. Apart from that, the question is not difficult. So let's start, right? Let's discuss. Okay. So how many of you solved the first two? These two at least. This one was very easy. Right? This one should have been done like there is nothing much to do over here. In this particular question, there was like a small trick. If you figured that out, then you got the solution. And the third one was, okay, question was a little bit tricky to understand. Chalo. Okay, so let's see, right? What? Okay, so let's start with this one. So what is this telling? This is the easiest one, right? It is telling that we are given a string, something like this, and what we have to do is we have to convert it into a string like this. Basically, every dot should be replaced by a square brackets and a dot. Okay. It has even mentioned like to use string builder. Again, remember string concatenation is bad in strings. If you use string builder, you get O1 complexity. Right? Same logic, right? If this should have not been mentioned, then also you should have you should have gone for string builder, right? Okay, that's it. You just have to use a string builder. Let's say result is equals to new string builder, and you can do empty string. Okay. Now what you can do is you can simply traverse through this given string I is equal to 0, I is less than n, I plus plus. If s dot caret I, if this is equals to dot, then we'll do something. Otherwise, we can simply append it at the end, right? Else we don't have to do anything. We can simply append it to the result. N is not defined. Thank you. So you can append it to the end. This is s dot caret I. Okay, done. Now we appended it to the end of this. Okay. And now over here, if it is a dot, then what we can do is we can do result dot append. We need to append it like this, right? We need to append a square bracket dot and then ending with a square bracket. That's it. Right. If it is just a dot, we'll append. If it is just a character, we'll append the character. If it is not a character, if it is dot, then we'll append this and return s. And the code. Oh, two string. It's not str. Okay, we are getting this correct answer. This should be correct. Now if we submit, it should be fine. Okay. Done. Okay, how many of you completed this? Anyone having doubts in this one? Just that you have to replace the dots with this, and you have to use the if it is not a dot, you have to use the normal string append. Right? So it was just you have to use string builder to append it, because if you use string concatenation instead of this, it would be order n, so the entire complexity will become n square, right? here the constant was also 10 to the power 5. So n square is not acceptable, but this is fine, right? This is fine. This is order n. Okay, that's it. Okay, let's move to the next one then. Now this one is interesting. So what it has told that we have been given like two arrays. Okay, I'll explain the question first. So I've given two arrays, right? So this is the seat numbers that are vacant, right?
Sir, excuse me.
Yes.
Sir, this was not the question that came to the contest.
It
So the
was
second question was increase it.
which so I got these three questions. Is this not the question?
No, sir, this was not the question.
No, sir, this is not the question, sir.
Okay, I should check once because I got the link as this one. Just let me validate it for just a second. Mhm. I got this one itself. Okay. Okay, so what was the question then? Because I got this link. Let me take a share. Just a second. Okay, sorry for that. Let's check. Okay, then let's search. What's the name of the question? It should be there in the gym, right?
Sir, it was increase it.
Increase it.
Yes, sir.
No such question. No. Okay.
Sir, it was a medium level question.
Okay, let me just. Okay, let me connect. Just yeah. Hello. Okay, I've informed like okay, so you have the lead code link. Okay, we'll discuss the lead code one if that doesn't come up. So this was the correct, right? This is the third question is same private and safety one. Yes.
Yes, sir. The third question is.
So let's discuss this one in the meanwhile. So by the time we get that question, okay. So we'll discuss this one also. This one is also, I guess, the similar kind of question, right? So here also you are have asked to increase. So since I've opened this, anyone has solved this question? From gym anywhere? Did you got this question? Get this question solved it? No. So we'll discuss this one. This is an interesting question. Okay, let's discuss this one meanwhile. Okay, how many of you solved this one? I was surprised if anyone solved. Yes, that's great, Vishnu. Chalo. At least some few of you solved. Okay, I see the question is easy, right? Only the words are difficult. Otherwise, it's a very easy question. Okay, let me explain this. What the question is asking. So see, the question is telling that Ryan is in a battlefield, right? So his superior asked him, instructed him to look at the given string that consists only lowercase letters. So the first thing is that is told to us about string is that it has lowercase letters, right? So we can so it is A to Z, that's 26 characters, right? Other apart from that, there is no other character. Okay, let's see if we can use this information somehow, somewhere. Find the frequency of the maximum number of substrings such that, okay, we have to find the frequency of the maximum number of substring. Okay, so we have to count the frequency of a substring such that the string starts with that substring, the string ends with that substring. Now, what does this mean? So, for example, let's say this is a string A, B, A, C, A, B, A, Z. Okay. So, for example, here, what's the substring? Yes, of course. Okay. Yeah. So let's say this is the string that is given to us, right? Now, what it has told that the substring that we have to consider, right? The substring that we want to count should be present at the start of the string. The string should start with that substring. The string should end with that substring. Now, is there any substring with which the string is starting? So, for example, string is starting with A over here. Is that substring present at the end? No. If we consider AB, is that the substring that is present at the end? No. If we consider ABA, is that the substring present at the end? No. If we consider ABAC and this, is that the substring present at the end? No. We can even consider this substring from the start and this substring from the end, right? So basically, we have to figure out a substring that is present at the start and that is present at the end. For example, let's say if this was not AZ, this was AB, right? So this substring is present at the start and this substring is also present at the end. So we got a substring that is present at the start and also present at the end. Now you have to basically count the frequency of this substring, right? If there are several such substrings possible, you should have highest frequency in the given string. So basically, let's say here there was so here we have ABA. Let's consider this string A. So here, if you consider A, this is also a substring that is present, right? So this is present at start, this is present at end. If you consider AA and you consider A, so this is also a substring that is present at start and it is also present at end. Now you have multiple substrings that you can consider. If you consider AAA, you have AAA at the end as well. So you can consider this as well, or you can consider this as well. So you have multiple strings that that can be considered in such a scenario. So what you do? So you have to consider such substring such that the frequency will be highest. Acha. Now, does it look like the problem that we solved? So for example, if you take a larger substring, right? Here, if you take a larger substring, like very large substring. So here, this is the substring that you took and this is the substring that you took. What's the frequency that you'll find out? A small number, right? But if you take single A as a substring, the frequency of small a would be higher as compared to this particular substring, right? So you have to find out the maximum in such a scenario. Since we have to find out the maximum, so we'll take the smallest size substring, right? So we'll start with length 1, length 2, length 3. If length 1 substring matches, then we look for that, right? We don't need to check for length 2 or length 3 because because it would be length 2, length 3 frequency would be lesser as compared to the length 1. Okay. Getting the idea? Okay. Okay. So this is what we have to do. Let's check the examples that's given, right? So basically what you have to do is consider BBB. This is the example that's given. So you have to consider a substring that is present at the start. So let's consider B and that is present at the end. So let's B. Okay, this is present at start and this is present at end. What's the frequency of this? the frequency of this is 3, right? 1, 2, 3. There, if you can consider BB, it is present at start, it is also present at end. Now, what's the frequency of BB? It is 1 and 2. So you get the frequency as 2. You can consider even triple B, right? This is present at the start, this is present at the end as well. Now, what's the frequency of this? 1. So which one is your result? Your result is this. So basically, we'll start by 1. We'll consider if we get 1, if we will consider if we get 2, if we will consider if we get 3, right? So such that we get the maximum. If we start with the smallest length, there is the maximum chance of finding out the maximum frequency. If we consider the larger length, we'll get a smaller frequency. We'll check that. We'll check which length is present more or not. Okay, that we'll check. Now consider for the same thing over here. For example, AB. So we got AB is also present. A not present at the end, right? AB present at the start, present at the end. So let's count how many occurrences of AB is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 occurrences of it, and it is output is 10. Understood? Firstly, tell me understood the question, then I can tell you the approaches of the solutions. Now understood. Okay. I know, like it was mentioned clearly, but first instance, I'll be honest, in the first go, I also did not understand what it is asked. Right. Then after reading it multiple times, I got okay. And I don't know why it is marked as hard. It was, I guess, April Fool prank that was that happened with you all, because this is a like at max medium question, right? Not it's really difficult. Let's see the solution. Is it really difficult? It's not really difficult. Okay. Okay. So let's start with this, right? So we need to find out the substring. So let's consider string builder. S is equals to new string builder. Let's say this is substring 1 S1, okay, which is empty initially. And then we have substring 2, which is also empty. Okay. Now we have a string for which we have to find out a substring that is present at the start and present at the end. Okay. So let's check, right? How can we do this? So we'll start from the starting, that this is the so we'll start with length 1 and we'll go to the maximum length can be n. Right? The smallest length substring that we want to consider is 1. The largest length substring that we want to consider is n. Now, what are these two substrings that we want to get? So let's write that logic. Let me write that logic. Let's not use the inbuilt function. So I want to run a loop that will start from 0 and it will go till 0 plus I. It will go till I, right? So this will find out the substring of length 1, length 2 from the starting. Right? So I can simply do s1 dot append, and we can do s dot caret I. Okay, so this is the first substring that we want to find. That you can use the substring function as well, does the exact same thing. And if you are using string builder, basically you have to convert this into string builder, so you can get a order and complexity for that as well. Right. So this is also order n, not a big problem. We are starting for firstly, we are finding out length 1, right? So 0 to 1, length 1, then we'll find out length 2, then we'll find out length 3, and so on. Okay, next question. Let's find out a similar substring from the end as well. So what's the substring from the end going to look like? So we are going to start from not from 0. We are going to start from n minus I. Yes, n minus I, and we are going if this should be greater than n minus 1, last index, and j minus minus. Okay, and we can do s2 dot append s dot caret j. Yeah. No, sorry. This is why this would be plus plus. Yeah, this is fine. See, so the first iteration, what is going to happen? This is n minus 1, right? So we are going to get n minus 1, and it is going to run from n minus 1 to n minus 1. So we are going to get this character. Next iteration, we are going to run from n minus 2 to n minus 1. We are going to get AB. Next iteration, we are going to run n minus 3 to n minus 1. So BAB. Next iteration, we are going to run from 4 to n minus 1. So AB, we are going to get this. Understood? Yeah. So first iteration, we are going to get this, and then we are going to get this, right? So we got these two strings. Clear? Doubts? So let me print both the strings. I guess it might be clear then. System.out.println S1 S2. You have to return an integer. Let's take this one for simplicity.
Sir, I is less than or equal to, sir, here
Oh,
in line number 10 में.
but then it's equal to, right? So equal n minus n is going to be 0, 0 to n. This is fine.
Line number 10, sir.
Uh-huh.
Inside the for loop, I less than or equal to n.
This should be equal to, right? It can be equal to the length can be equal, right? That's what I'm trying to check. It can be equal. Index out of bounds from where it is. Oh, this is J. Yeah, that's coming from there. So this should be equal. This is the length, right? So this is just 1, 2, 3, 4. That is the length of the strings, right? This one is basically running for the string. So this is 0 to n. This is anyways going to run from 0 to less than I. That is less than n.
No, okay.
It is starting from 0. Okay. When it is n, so this would be 0. So that's in there much. Fine. Okay. Why did we not get AB? Maybe? Oh, I did not do this. Okay, just a second. Before every iteration, we have to just mark them as empty as well, right? Okay, let's do it. Just okay, since it is similar, okay, can't. Oh, sorry. Let's select both of them, just move them inside the loop. Okay, see this one. So see what we are doing is firstly we are finding out the string of length 1 that is present at the start and present at the end, which is AB. Then we found out the length string of length 2 that is present at the start, that is AB, and present at the end, AB. Okay. So see, S1 is nothing but the substring that is present at the start from index 0 to I. Right. Firstly, I is 1, so we'll find out length 1. Then I is 2, we'll find out length 2. I is 3, we'll find out length 3, and so on. So this is just finding out the substrings that is of length 1, 2, 3, and so on. This is finding out the same substring but from the end, right? So ending index is n minus 1, that is fixed. Our starting index is going to vary, right? So firstly we are considering this length 1, so it is n minus 1 to n minus 1. Then we are considering length 2, so it is n minus 2 to n minus 1. Then we are considering length 3, so it is n minus 3 to n minus 1. Okay, understood? So see, we are getting A, B, then A, B, A, B, then A, B, E, and from here B, A, B, right? So we're getting the 3 length, 4 length, 5 length, and so on, right? So this is how we are getting the strings. Understood? Second J loop. Okay. What have we done in the J loop? See, J loop में क्या करना है? So our end substring is we have to find this one out, right? Everyone understood? पहले B find करना है, फिर A, B, then B, A, B.
Sir, आई वाला लूप क्या लेंथ के लिए है?
हाँ, I loop is for length. This is for length. And this is for the substring 1 and this is for the substring 2. So substring 1 is from the start, substring 2 is from the end. Okay, so starting is substring, if you have to find out the substring of length 1 from the start. So how is your loop going to run from 0 to 1? If I tell you to find out this substring, let's say length 5 or length 6. So how is your loop going to run from 0 to 6, 0 to 5, something like that, right? You append it at the end, you get the substring. यही तो substring का logic है, right? And the second one is also done the same, just that we are running it from the reverse. We are running it from the end. So this is n-1, n-2, n-3, n-4, and so on. Okay. So we are running from n-1 to n-1, then we are running from n-2 to n-1. Check. When I is equals to 1, okay, first iteration I equals to 1. So J loop is running from 0 to 1 for this one. So 0 to 0, we get A. Here J loop is running from n-1 to n-1, so we get this. Basically here also it is running from 0 to 0, right? So it will get A, sorry, B, the end index. Okay. Last substring, first substring of length 1, last substring of length 1. Now second time when I will be 1, we'll run it from 0 to 1, right? Less than I, so we'll run it from 0 to 1, and this one is running from n-1, n-I, so n-I is 2, right? So this is n-2 to n-1. So we are going to get AB, and here also we are going to get AB, 0 to 1 AB, and this is AB. Got it? So AB, then AB, AB, then 3 length, then 4 length, and so on. Now understood? Okay, what we are trying to do. Now, what is the question telling? That once, so you find out the substring from the start, you find out the substring from the end. Now, if the substrings are equal, you have to find the frequency of that substring. Okay. So if these two substrings that we found out, if S1 is equals to S2, or let's not take it this way, S1 dot equals S2. If these strings equal, then what we have to do is we have to find out its frequency. Right now, how do we find out its frequency? Let's check. Figure is 10 to the power 4, so n square is fine. Let's check if we can do some optimization over here, right? So if I go to find out the frequency of it, it is an n square operation. I don't think it like if there is a length 2 string that we found out, there can't be a length 3 string having greater frequency. Can there be? Let's think of a string like this. So let's say this is ABA, and at the end also we have a ABA. So this won't match, right? Okay, so let's say it is only A. Okay, check here. Okay, let's take a example. So here, if the one length string is matching, so the you have a maximum chance of finding out that substring. Let's say this was AB. So this won't match, right? If this was a different character, it won't match. So let's say we found A and all of this are B. This is A. See, you cannot have you cannot build a scenario where if you consider 2 length or 3, if you found out a, let's say, if you found out a 1 length string which is matching, and you'll consider a 2 length or 3 length string, you'll get a higher count. You cannot figure out a scenario, right? There cannot be an example. Take I'm just trying to take those examples. See here, like, so for example, if this is the string, right? So let's say this is the string A. So here you what's the character that's matching? One length string is matching. Now, since the one length string is matching, we can there is no need of taking a 2 length string. That if you consider a 2 length string, you are going to get a lesser frequency as compared to 1 length string. So if your strings of length 1 is matching, you don't need to consider the strings of length 2 or length 3 or any further length after that, right? If your length 2 is matching, then you can stop, or length 1 is matching, you can stop there. And you can check what's the frequency of this particular substring in the string. Okay. So basically, that is simply telling that we can count the frequency of the string, whichever length is minimum. Okay. So let's store this string. So what we can do is we can have a string s is equals or string result is equals to empty. Okay. And we can put this into the result. Result is equals to s1 dot to string. Okay. Now basically we have to find out the substring in the and we can break here, right? We don't need to find out any other substring. Okay, we can break. So what I did, if I found out a string of length 1 or length 2, whichever string, right, whichever is the smallest length string that first matches, we'll just consider that is a result string, and we have to just count the frequency of that string. Now we are left with a very simple question. That's why we are given a string which is stored in result, and we have to count the frequency of this particular string in the entire string. That's it. So we have to count the frequency of this string. So what we can do is we can start from the starting. And what are the substrings? Right, so our substring can first, so let's say this is our string that we want to compare it with. So string builder sub. Okay, we'll find out different substrings in the string of the same length empty. So you have to find out substring that is of length exactly equal to the result, right? So exactly equals to the result. So we can check here if result dot equals, it is empty string. That means we did not find any such substring which is matching. So we can simply return 1, that is told in the question. So for example, it is telling that if you don't find any such substring that exists, then you print 1. Okay, so in that situation, we are simply returning 1. Okay. Otherwise, what we can do is we can count the frequency of that substring. We can count is 0. We can take a length of that substring as well. Let's call it as R, which is result dot length. Okay, so found out the length of the result string. We found out we took a count as 0. If the result string is empty length, like this is empty string that we as we initialized it initially, that means we never initialized it to something else. We did not find any substring. We can return 1, which is asked in the question. Now what we have to do is we have to find out all such substrings which will be equal to this particular string that we have. Okay, so we can what we can do is we can find out a substring. Let's say our substring will be starting from index I, and it will be going till the index I plus the length of the string. Okay, j plus plus. So let's say it is of length 2. So we'll go from 0 to 0 plus 2. So that is 0, 1. That's fine. We'll append this substring at the, we'll use append to find out this substring. Or we can use s dot caret j. So this will give us the substring. So for example, firstly we'll get a string of length. So since let's say we found out this as AB, right? So the result is AB. Now we'll find out all substrings in the string of length 2. So AB, BE, EA, right? We'll find out all the substrings of length 2. And what we have to check is if any one of them equals to the result. If result dot equals the substring, if it is equal, then we can simply increase our count. And this is our count. And at the end, we can simply return that this is our count. Understood? Not. So first tell me this part understood what we have done in this part. So we are finding out the string of length 1, length 2, length 3, and length 4, and so on. Whichever strings become equal first, right? Whichever string becomes equal first, that is our result substring. That is the string for which we have to count the frequency. Okay. So what I did, I just stored it in a result, and I told for this string we'll find out the frequency. Okay. We break the loop. Okay, this we stored in the result. We broke the loop. Now over here, what we are trying to do is, which we are checking if it is equal to empty string. That means if it is equal to empty string, that we have not, we have basically not put we have not put anything into this string. So we can simply return 1. It asks in the question if there is no such substring which is present at the start and present at end, return 1. Now, after we have got this substring, let's say there is a substring that exists, what we have to do is we have to find out all substrings in this given string of this length, and we have to just compare whether it is equal to that substring or not. Okay, so what we are doing is we are finding out the length of substring of length 1, same length, substring of length R. So we are starting with 0. So what's the substring of length 2 starting from 0? That is AB. We are finding out the substring of length 2 starting from 1. We are finding out the substring of length 2 starting from 2. We are finding out the substring of length 2 starting from this, and so on. Once we find out all the substrings, every time we are getting a substring, we are just checking whether it is equal to result. If it is equal, we are increasing our count. That's it. Okay. So let's check for this input. We should be getting 10. Oh, we are getting 1. Why? If it is equals, then we break. अच्छा, let's try to print the result. I guess 1 तो यहीं से आ सकता है. Dot println. So it is empty. Why is 1 empty? 1 is empty because this assignment did not happen. Now, why is this assignment not happening? Shallow copy, deep copy. Result is equals to empty string. Or is just a second. Let's take this as string builder. Yeah. So this one you're telling equals is not working over here. To string, we have to convert to string to compare. I guess we can compare it without to string. So this false. Just using this then. Just a second, let's check. Let me just get rid of this logic for a second. Okay, we are getting AB. Now we are getting AB. It equals works only in strings. I guess string builder maybe it works fine, right? If two string builders are equal. Okay, chalo, anyways, this is working in this way. We're getting result. Result is AB. Okay, now we get result dot length. Okay, which is R. Okay, this one we have to run till R, not N. And now if I run this, the result is string builder, and this is also string builder. So this one also we have to do then for string. They're getting 1, which is oh, sorry. This one should be running till N. Why this is running till R? This should be running till N, right? So, got it. So here basically we have to do, this should be less than this, and J should be less than N. Got it. Yes, n minus r should be the scenario, or you can check for directly less than n, that's fine, right? Okay, let me explain what we did, right? So there is nothing changed, right? So same logic, just that we have taken this result as string builder. There were some problems of string. We just converted it to string before comparing with equals. Equals, I guess, is not working for string builders. So now we are converting to strings, comparing it. We are storing that result, same thing. Now we are trying to do the same thing. We are trying to just compare it. Here, just I made one small change. See, when I'm just doing for I plus r, so I can be n minus 1. So n minus 1 to r, this is going to be problem. So either you can do it minus r over here, right? Whatever is the length, you can run for minus r, and that's going to be fine. Or you can do less than n, whichever one you prefer. This one is better. I guess we have less number of iterations over here. So this is like better. Nine n minus r plus 1 होगा. Just a second, n minus r. So it is that length. So you can put equals to. No, I 0 to 0. No, this would be 3 length, right? So this one, this would be 3 length, n minus r plus 1 over. Yeah, it is n minus n equals to n minus r or n minus r plus 1. Okay. Yes. Okay, so this would be, you can run this for n minus r. Basically, here we are running for n minus r is this particular index 0, 1, 2. So this is n minus 2, right? So this index, we should be running it till this index, because this is the last index where we will be finding the string of length 2, right? So you can run it for n minus r plus 1 or equals to n minus r. 0 to we can start with the index 0, and we can last index that we should be considering to find out the substring is n minus r. Okay, that's it. Now if I submit, should be fine. Okay, done. Voltage is passed. That's it. Yes. Achha, now tell me, was it difficult? Actually, it is marked as hard, but I don't think it is difficult. The question was also like in one go, it was a little bit tricky to understand, but if you read it multiple times, you'll get what it has asked to do, right? And from this example, if it has not given this example, then it was difficult to figure out. But in this example, it has clearly mentioned, right? This is the substring which is present at start. It is present at end. So you have to find out that substring. Once you find that substring out, what you have to do is you have to count the frequency of that substring in the entire string. So it's basically simply finding out the frequency of a string in the given string. So how will you do that, right? So you just try to find out the string of its length. So your length of that string is r. So find out all substring of length r starting from 0, 1, 2, 3, and so on. To find out every substring, you just compare whether it is equal. If it is equal, you increase the count. If it is not equal, then you don't do anything. Finally, return count. That's fine.
Sir,
Yes.
sir, I did it in a different way. Can you please have a look?
Yeah, sure. First running
Sir,
for
सर थोड़ा GDB पे पेस्ट कर देंगे सर एक बार सॉल्यूशन.
I'll share all the solutions, don't worry.
Sir, I pasted in the chat, sir.
So you found out the character. So you are using character concatenation.
Yes, sir, but only for actually I use in similar to the 2-point approach. I fix the first letter, and
The first letter is not equal, then you the start and end are not equal, then you just add that character to the end. Else
yes,
you,
and if it matches, add that character and break the loop, sir.
So anyways, you're adding that character to the end, right? So you can use string append function there. That will reduce
yes,
the.
Actually, I didn't took more time to find any optimized ones, sir.
That's just a suggestion you can use there. That would be fine. After that, once you got that, you can, what you're doing is you're checking if it is equals to the substring of length I to I, n plus n, I plus n. That's fine. Yeah, this is the correct one. N plus n count plus. Same approach, right? You have done the exactly same thing. Second part is like fine, you have used the substring function, but yeah, since S is a string, both of them is going to become costly. One optimization that you can do is you can just use string builder. So that would make the first loop order n, and second one would be n square. Right now it is n cube, second one.
Yes, sir.
Okay, that's fine. That's correct. Okay. Okay, understood everyone? I guess yeah, people's prank ही था to mark this as hard because I don't feel that this should be marked as hard given right now what we have understood, what all we have questions we have solved. So at max medium level, I'll say. Okay, I guess the question is shared to me. Just a second. Let me firstly finish this project. Let's start a new project. And save this. That is contest 4, right? Yeah, contest. It is 3 or 4. It's
Sir, 3, sir, 3.
3, sir.
3 March. Let's now go to this. So this was one question that we discussed. This is the first question, right? Which is like to count the dots. This one is not there. This one is the second one, right? Okay. Then let's discuss the third one. Just a second, let me open that question. Okay. I guess this is the question, right? Let's check this one. This one is marked as medium. Okay, so this is like I also have one more question that was shared to me by mistake. So anyways, we'll discuss this one as well. Okay. So what it is telling that we are given an array of an integers. He is playing Bob has an array of an integer. He is playing a game. He has to make all the elements of the array unique. To do so, he can increase the value of values of any elements of the array. He needs to spend X coins to increase the element of the array by X. You have to find the minimum number of coins that he has to spend to make all the array elements unique. Okay. So complete the driver code. So it just has to increase. It has not even asked he can decrease. He can simply increase. He cannot decrease the thing. Okay. Now this is very easy if you just apply one trick. But in medium, I'm missing one edge case. For example, this. Five, 6, 7, 8, 9. So it should be 10 and 11, right? 5 should become 10, 6 should become 11, right? So I'll explain this question, what it has told now. See, so basically you have to just increase, right? You cannot do anything else. The only operation that is permitted is to increase. So this is the array, right? 2, 4, 2, 4. What you have to do is you have to make all the elements unique by increasing it, right? So all the elements unique by increasing it. So for example, this element, you can this is unique. You don't have to do anything. This is unique. This can be made unique by increasing by 1. So this becomes 3. Now this can be made unique by increasing it by 2. So this becomes 5. So you perform one increase operation over here, one increase operation over here. So total 2 increase operations is required. Now here when the array is 1, 1, 1. So if this is unique, you don't do anything. You increase it by 1, it becomes 2. This is this you increase it by 1, it becomes by 2, it becomes 3. So total 2 increase operation over here, 1 increase operation over here. So total 3, right? So your output should be 3 over here. Understood? Wide buffer reader is used in the driver code. whoever created the question, he is like more comfortable by writing buffer reader, so he wrote buffer reader. That's it. I don't see any other reasons. Whoever created this question, right, or put it in the platform. So there are multiple creators, right, who continually create questions and put it on the platform. Problem setters. So he might have felt this would be like he might be used to writing buffer reader, so he used this one. Okay. So, now how much of you got any idea of this? How many have solved this? बहुत easy है. Just अगर decrease होता ना, then you have to think, right? अगर decrease नहीं है, then there is nothing to think. Only 2 test cases per. The answer is sorting. You have to sort the array. See, once you sort the array, right? Once your array is sorted, then what you have to do is you get that. Okay, once the array becomes sorted, then you have the element that can be stored. Okay, sorry. You have the element that can be made unique, right? So for example, let's say this is once you sort this array. Okay, so you get 2, 2, 4, 4. So this is unique, you don't have to do anything. This is not unique. So what you'll do is you'll increase it until it becomes unique, right? So you'll keep on increasing it until it becomes unique. So you'll increase it by 3, it becomes unique. That's it. Next, you'll so basically you have to make it strictly higher than this. So whatever is this number, if this is smaller, right? This, if you sort this number is either going to be equal to, it cannot be smaller. It is either equal to or it is larger. If it is larger, then it is unique. If it is equal to, then you have to just increase it to a number such that it becomes unique. That's it. Now let's think of this edge cases, right? So we thought of a solution, and let's think of the edge cases that may arise because of this. Okay, so one edge case could be like this. So for example, we have 2 and next number is equals to 2 and this number is equals to 50. So in this situation, what's that you have to do? You have to just increase it by 1, right? You'll increase it by 1, so it becomes 3. Okay, it becomes unique. So you just increase it by 1. If it is equal, it becomes unique, right? You don't have to do anything. Now consider okay, like situation like this. You have 2, this is 2, 2, 2, 2, and then you have. So is there any other way by not increasing it? So see, so we increase it, this one to 3, then we'll increase this one to 4, this one to 5, this one to 6, right? The previous plus 1. Now these all numbers should also be increased to this should be increased to 7, 8, 9, 10, 11. Now let's think, right? Yes, but how? Okay, how we'll come to that question, that is like implementation, right? Let's think of whether this approach is wrong or not. So here, what's the delta that's coming out? Here getting 1 plus 2, 1, 2, 3, 4. Here we are getting 4. 5, 6, 7, 8. I don't think there is any other way, right? This is the minimum you will get. You cannot get minimum in any by doing anything else apart from this, right? So because, for example, if you increase this to 4, 5, 6, so if you increase this to 4, 5, 6, 7, 8, so delta would come out to be 1, 2, 3, 4, 5, and here you will need to then increase this to like something like 6, 7, 8, 9. So here your delta would be 4, 5, 6, 7. So 1, 2, 3, 4, 4. Achha, you get the delta as 1, 2, 3, 4, 4, 5, 5, 6, 7. Achha, here you are getting what the delta as 1, 2, 3, 4, 4, 5, 6, 7, 8. So instead of 8, you are getting 5, which is better.
So, but the sum is equal, right?
The sum, the sum is equal. Let's
Yeah,
check.
because
Oh, the
there
sum.
there 8, and here we have 1 7 and 2 5s, right?
Just a second. So how did this come out to be 11? This changed to 11, right? So we got this as 6, 7, 8, 9. We change this to 4, 5, 6, 7, 8. No, sorry, 4, 5, 6, 7, 8. So we cannot change it to. Oh, sorry, I guess I did a mistake over here. 4. So we change it to 4, 5, 6, 7, 8. And we could start with. Just a second. हम मम्मी क्लास में हम कॉल करते क्लास में. Okay, sorry, I guess यहाँ पे 4, 5, 6, 7, 8 है. Here there is a repetition that I made, right? This should be unique. There should not be any repetition. So we cannot change it to 3. 3 is then 4, and then anything after it is also taken. So 3 is not taken. So we could have left one of them as 3, and then the others would be 4, 5, 6, 7. So we need to then start with 8, 9, 10, 11. Oh, so we still go to 8, 9, 10, 11, and here the delta would be, let's try to find out the delta. So here the delta would be, so this would be 0, this would be 1, this would be 2, this would be 3, this would be 4. Right, here we get it as 6, 7, 8, 9. Okay, so we get 0, 1, 2, 3, 4, 6, 7, 8, 9. We don't have a 5. Okay, we don't have a 5. 3, 4, 5, 6, 7. That's fine. We cannot do anything over here. I guess this would give us the minimum if we do it in this way, sort it and increase the adjacent ones. Somehow any other way is going to give us a higher number. So here we are getting a delta as 9. As well, here the highest delta was 8. So, and we are getting 8, 8 cancels out, 7, 7, 6, 6 cancels out, 1, 2, 3, 4 cancels out. 9, 0 here we have 8 and 4. Okay, so this is better, right? The second one, yes, it should be 2, right? The second one, अच्छा एक 2 भी रहने दे सकते, right? We could have left a 2 as well. So okay, we could have left a 2 as well. So this would be 8, 9, and 10. So this would be 0, 6, 7, and this would be 8. So the second one is clearly better. So let me show you this. Okay, let's take this as example. Okay. So one approach is you just keep on increasing this. So this is 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11. This is one approach, right? This is how you change. The second one, let's try to change it in this way. So firstly, we leave a 2 as it is. We leave the 3 as it is, and we just increase this. So this will become 4, 5, 6, 7. And we increase this. So this becomes 1, 2, 3, 4. Okay. So this is the deltas that we get. Okay, so these are the two arrays that we get. Now let's find out the delta in both the cases. So the first one, the delta is 0. Here the delta is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's find out in the second case. So it is 0. Here the delta. Oh, we cannot change it to 1, right? This we cannot change to 1. So this can be.
You have to increase the value, sir. Only increase.
So this one we cannot change to 1. Okay. So this would be. Okay, let's take. So we have taken. We cannot. So this is 3, right? So 3 would be 3. 3, 4, 5, 6, 7. We can take then. There is no other values left. So we can have to take 8, 9, 10, 11. These are the values that we can take. So this would be 6, 7, 8, 9. This would be 0, 1, 2, 3, 4. Right? 4, 4 cancels out. 1, 2, 3, 1, 2, 3 cancels out. There is a 0. There is a 0 that cancels out. So we are left with 8, 9, 6, 7, 8, 9, 6, 7, 8, 9 cancels out. Here 5, 0. The second one is better, right? The sum of the second one is better. Check for this one. So let's try to put it in the input as well. Did I miss something? Did I not follow any rule? We followed all the rules, right? So the first one is giving you the result as is higher by 5. So let's take 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we have to also tell the size, so the length is 10. Let's try to get the expected output. That's 40. 6, 1, 2, 3, 4, 5. Sum of all the numbers from 1 to 9. Oh, sorry. Yes.
So actually, this is what we talk in the first case. We need to sort and add plus 1 and compare with next whether it's equal or not.
No, see, okay. So see, so the initial approach that we took initially was we'll sort it, right?
Yeah.
Let me explain both of them. So initial approach that we took at the start, we'll sort this array. The sorted array would look like this, right? No matter however they are initially organized, the sorted array would look like this. Now what we have to do is, see, so we are increasing. So we'll say 2 is remain as it is. It will become 3. It will become 4. It will become 5, 6, 7, and so on. All of them will increase. So what's the sum that we are going to get over here? So let's find out the delta. So this is the delta that we'll get, right? If you look that this is the deltas that you are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this is the delta that we are getting. So what's the sum of this delta? So this is coming out to be 9 plus 9 plus 1, 10, 20, 30, 40, 45. This is coming out to be 45, right? Now let's check the second approach where I am telling we can do something like this. Okay, so what I'm telling here, let's check this one. So what I've done over here is, what we have done is we have just put 2 as it is, right? Now check this approach. Okay, so we have put 2 as it is, and then we put 3 as it is. Yes.
Actually, it's 0, 1, 2, 3, 4, 4, 5, 6, 7, 8, sir.
Yes, sir. Sir, you calculated the delta wrong.
4.
Yes, sir.
4,
5, 6, 7, 8.
sir.
Then it will come to 40.
Okay, it will come out to 40. Okay.
Yes, sir.
So this is 4, 5, 6, 7, 8. So we decreased 5. So this is 40. Okay.
Yes, sir.
Let's find out the second one. Just if the second one is equal, then we are done, right? Then our approach is fine. So we are just checking.
Both are equal, sir. I just verified now.
Okay, so this is 2, this is 3, right? Okay.
Yes.
This would now this all we are changing 3, 4, 5, 6, 7, and here we are changing 8, 9, 10, 11, 10, 11. Okay. So here the delta is coming out to be 6, 7, 8, 9, which is fine. Here the delta is coming out 0, 1, 2, 3, 4. Okay. Now add this one. What we are getting? So this is 10, this is 20, this is 30, this is 40. Yeah. So this is coming out to be same. Right. So delta is basically the sum, right? This is the sum of the differences that we are getting. So we are calling just it delta. So this is here also we are getting 40. Here also we are getting 40. So it doesn't matter whichever one we are increasing first. Ultimately, since we just have to increase, our final sum will come out to be same. See, I just showed you 2 ways how we can get this, make this array unique. One way was using this, right? Where we just increase every adjacent one by 1. So we increased 2 to 3, 4, 5, 6, 7, and we kept on increasing it by sorting. And now here, the second approach was we mark 2 as it is, 3 as it is. We first increase the later half, and then we came to increase the first half. The sum is coming out to be same, so it doesn't matter whichever one we are increasing, right? So the so this is why I did this, just to validate before writing the code that we are writing it correctly, right? So remember, sometimes we wrote code, it goes wrong, right? So these are the cases that we don't check while writing, right? What if we consider, okay, this is fine, but here the differences are going to come out to be lesser, but this is going to increase the differences over here. So the final sum is coming out to be same, right? So we don't have to worry about that. Okay. So let's do it in this way. So what we can do is we can first sort this array. Array.sort. I don't see any problem here. So this is login. Now what we have to do is, so the array is sorted, right? So every consecutive number, right? We can take a count which is 0 initially. We have not increased anyone. So every consecutive number will just try to check whether it is whether it is unique from its previous one. If it is not, then what we'll do is we'll increase it. So basically, what we'll try to do is we'll just go from for every number. Let's say we'll start from I, right? 1, because first number is anyways unique, right? So we don't need to check anything for the first number, that is anyways unique. So what we have to do over here is, see, for A of I, we have to make it unique. Now it either it can be like unique itself, or it cannot be unique. When it will not be unique, it will not be unique if it is basically equal to the previous number, right? So since this is sorted, so either it will be unique or it will be not unique if it is equal to the previous numbers. For example, if you sort this array, you're going to get 2, 2, 4, 4. So here, this one is, so 2, 2 is not unique because this is equal to the previous number, right? This is equal to the previous one. This is unique because this is not equal to the previous one. That's it. Okay. So what we have to do in this situation is, we'll just check, right? We can check if A of I is not equals to A of I minus 1. If it is not equal, then we don't need to do anything, right? If it is not equals to I minus 1, then we don't need to do it. If it is equals to I minus 1, right? If it is equals to the previous number, then what we have to do is, we have to just increase it by 1. Okay. So I guess so. So count is equals to count plus 1. We'll just increase it by 1. A of I is equals to A of I plus 1. Okay. We just increase it by 1. That's it. I guess so. This should be fine. And then we can return it. A of I is less than I minus 1. That cannot happen. A of I cannot be less than, because the array is sorted in ascending order. That's why you applied sorting, right? So A of I cannot be less than. So this cannot be 1. The next number will always be greater than the previous one. Okay. Either it will be greater than or it will be equal to. If it is greater than, that's unique. We don't have to do anything. If it is equal, then we'll increase it. Okay. Just try to check for this one. Are we getting 40? Oh, sorry. This is A of I minus 1 plus 1. No, A of I. So we have to. Okay, sorry. Just a second. So we have to increase it by n is equals to A dot length. So we have to not increase it by 1. We have to increase it actually by the difference A of I minus A of I minus 1. So plus 1. So whatever is the difference plus 1, right? Let's run this code once. We are getting 1.
Sir, actually, we can do is we can start from 0. We can compare the both elements. If it is equal, we can increase the count for the next element, not for the previous element.
Okay, got it. So okay.
In that way, sir, again, when it is compared from the next element,
so actually it won't be equal, since we are updating the previous one as well, right? So either we just increase the count, or
so why we are updating the previous number?
Yes, sir.
If we
We can directly do A of I is equal to A of I plus 1, right?
This will work.
Actually, we are checking for.
Yes. So this is fine, right? Yeah, this is fine. So this should be fine. If we don't update it, the previous numbers will get this as delta.
Yeah, and we can update the count by 1,
this
right?
is count will be plus. Okay, increase it. Yeah, so we can just decrease, not by 1, right? Count won't be increased by 1. Count would be increased by this.
So we are checking for A of I is equal to A of I minus 1.
No. Okay.
Both number are equal.
Okay, let me.
So we can only.
There are a lot of edge cases over here. See, let's say what we want to do. Let's make it clear first. Okay. So what we want to do is, we just want to see. So if this is 2, that's fine. The next number is equal, right? This is equal. So what we have to do is, we have to increase it to 3. Now, once we increase it to 3, our count should be increased by 1. So because this is a of I minus whatever is the new a of I that we got, right? So we have to create it as new a of I. So it is a of I minus 1 plus 1. Okay. And whatever delta we have, that is our. And do we need to actually update it? That's what I'm thinking. If we don't update this, if we remove this, okay, let's check, right? So if this is equal, so what we do is we are just counting, count is equal to a of I minus a of I minus 1 plus 1. Okay, so we are just doing this minus this plus 1. So this minus this plus 1 is 3. Okay, next we are doing this minus this plus 1, which is not going to work because this minus this plus 1 and this should be 4, right? So it should be, we should have changed this. And if I should have been increased first. I guess so. Okay, now what we are doing is see. Now check what we are doing, and we can just remove this equal. Check equal is no more required. Check this one. So what we are trying to do over here is check. So firstly, we have this array, right? So what we are doing is we are telling let's update this array. So we want to update this array. So this is 2. See, a of I is equal to a of I minus 1 plus 1. So this was first number, we are not doing anything. So this is a of I minus 1 plus 1. So this becomes 3. Now our count is a of I minus 3 minus 2. That is 1. Okay, so 3 minus 2. This is something we don't have to increase by 1. Okay, 3 minus 2, 1, which is fine. We change it to, and we have also changed it to 3. Okay, now this has become 3. Okay. This was initially 2. Now it has become 3. Okay. Next iteration, when this is I is at here, we are just comparing a of I is equal to I minus 1 plus 1. So this is 3 plus 1, that becomes 4. Okay. Now we are doing 4 minus 3. Oh, this should not be 4 minus 3. This should be 4 minus 2.
We can simply do n into n plus 1 by 2 if it is not equal. So we'll get a count for all similar numbers, right?
Okay, let me do it in a simple way. Okay. I'll put it into if conditions, that will look easy. So see, what we'll do is the first unique number is n. Okay. Let's call it as unique. That is a of I, a of 0. Okay, this is the first unique number. Now the second unique number, if whatever is the unique number, if a of I is equals to this unique number, right? Let's say if this a of I is equals to the unique number that we have. Okay, so then we have to update this number, right? We have to update this number. If it is not equal, then we'll not update this number and we don't do anything. Okay, if it is not equal, if it is not equal, then this becomes our new unique number. So unique number is this a of I. Okay, simple. Acha. Now, if this is equal to the unique number, so unique number was 2, the new number is also 2. So we have to make this, we have to update this. So how will we update this? So we have to find out the difference, and difference is equals to the current number, okay, plus 1. Current number is a of I plus 1 minus the unique number, right? That's it. So current number plus 1 minus the unique number. So current number is, let's say this. Not plus 1. Okay. Okay, there is a lot of things. So previous, okay, this is the previous. What is this? So this should be actually the current number. Okay, let's find out this. The current number is a of I. Okay. Current number is a of I. We have to update it to the updated number. Let's find out the updated number. Updated number will be nothing but the unique number plus 1. Okay.
सर ये वाला क्वेश्चन सर n square logic में हो सकता है?
N square में हो सकता है, but it can be done in order n as well. I'm just thinking of order n. N square is constant wise it is going to be fine. I'm just thinking, because we have applied sorting, now we can use this to our advantage. So basically we can check. Acha, let's do it in this way.
So I think we need to solve in n square, sir. because we need to check for
Sir, in squad में solve हो गया था sir.
or we need to make AFI is greater than
No,
AFI
actually it is
minus 1, right?
actually I got it. See, this solution is like this. Okay. Okay. See, if A of I is double equals to A of I plus 1. Okay. If these two consecutive numbers are equal, then what we have to do is we have to increase the second number, right? So the second
Yes.
number could be increased. So okay, let's find out this increased value. So this is like the highest value that we have in array, which is A0. So any other number cannot be equals to A0. It should be higher than that, right? So we compared these two numbers. So now we have to just so there can be two cases, right? So this number can be, let's say, not equals to, so this number is like either equals to the current A of I or it is greater than. If it is greater than, then it is unique. We don't have to do anything, right? So we can just at the end put this is the unique number new. Okay. Any other number to the right of it will be just higher than this. It cannot be equals to this. Okay. Someone is unmuted. Just a second. See, so what I considered A of 0 as the first number, which is unique. Then I told, okay, let's check for all the numbers which are equal. So if A of I is equals to I plus 1, then we'll increase I, right? I is equals to I plus 1, will increase I. Okay. And what we have to do with this A of I, we have to make it unique. Now, how can we make it unique? So we can make it unique by increasing it, right? So let's say we consider the previous number that we want to increase is 0. Okay. Previous increased number is 0, A of 0, sorry. Previous number is this. Now the current number should be greater than this, right? So the current number should be greater than this. So it should be just one greater in, and it's fine, right? So basically A of I should be previous number, whatever is the previous number plus 1. Okay. And okay, let's do a few things, right? So the current number that we have is A of I. A of I should get updated to the previous number plus 1. Okay, which that is how we want to update A of I. Now we just have to find out the difference. Our difference is count should be increased by count plus the difference between both of them. So difference between both of them is going to be A of I minus current. Okay, we'll just do A of I minus current. So this is the difference that we created. So for example, we increased 2 to 4. That is the difference that we created. Now whatever is the new A of I, that becomes the previous number. So at every iteration, we'll just mark the previous as new A of I. That's it. At here as well, we'll mark the previous as new A of I. Okay. Now I guess this should be fine. We're just validating. Then I'll explain this if it is fine. Index out of bounds, I plus 1. Okay, so here we have increased it. I is increasing by I plus 1. It should be if I is less than n and
So, so I just copied a same almost same approach in the chat. Can you please?
Yes, just a second. Let me just validate this. Okay, so let's check what we are doing over here, right? So and what is going wrong. Okay, so see what we are doing over here is we are firstly starting with 1, right? We are just checking. Okay, 1. We have assumed the unique number is so what is the use of unique number? Unique number का कोई use नहीं है. We just can take the previous number. इसका कोई use नहीं. We've never used it. Right. So we just want to take the previous number, which is A of I. Okay. Previous is equals. We enter this. This is equal otherwise. Okay. Okay. Let's check what we are doing over here. So firstly, we are trying to like check if I is less than n. Okay. We are just comparing A of I with I minus 1. This is fine. Here we are comparing. This is equal. So what we have to do is we have to take the current number is A of I, which is 2. Okay. The count we are increasing as count is equals to 0 plus 2 minus Okay, then we updated this, right? We updated previous number plus 1. So we changed it to 3. Okay. So now we are taking 3 minus 2, which is 1. So count increased to 1. That's fine. Now we made the previous number as 3. Okay, let me clean it out. Clean so that 2, 2, 3, 3, 3, 3.
Sir, can you please highlight the question like
let me explain this. Let me try to see what's wrong we are
no,
doing.
sir, just let me read the question by dragging the window.
Okay. So you want me to explain the question again, or
Sir, if time permits, then you can please explain the question.
so see, what the question is telling, that we have to make every number as unique. Okay. Now every number, we have to mark every number as unique, and the only way to do is by increasing it, right? So if we increase any number, right? So for example, if we increase, this is 2, 2, 2. So we have to increase this to 3 and this to 4. Okay. So they will become unique. Now what is the thing that we have to return? We have to return what's the delta of here 1, what's the delta of here 2. So how much increase we made? So we increased it by 1, increased by 2. We have to return the total sum, that's 3. So that is our result. So if on increasing any number by x, we spend x coins. So basically you have to return x, right? What is the total number of coins that you will need to spend to make every number as unique? Okay. So the simple strategy that I'm using is we firstly sorted it. Okay. Now once we sorted it, so what we have to do is we got this array. This array would become something like this, right? Let's say this is the duplicates as well. So this is the situation where we'll face difficulty. Okay. So now what we are doing is, if this is equal, right? If this is equal, then we have to increase this. If this is equal, we'll need to increase these numbers. So how will we do? So we are checking that this is a of I. If it is equal to the previous number, that means it is duplicate, right? So that means we have to increase it. Okay. So we'll increase it by 1. So this becomes, so what we are doing is we are marking this number, current number is 2. We are increasing the current number by previous number plus 1. So previous number was 2. So this we change to 2 plus 1, 3. Okay, so this we basically change from 2 to 3. This remained as 2. We increase the count. Count is like previous, this plus 1. So this becomes 1. Okay, count becomes, so we increase the count by 1. So this becomes 1. Previous numbers becomes 3. And the I increased by 1. Okay, so I increased by 1. Now next iteration, we'll compare. Okay, now since we have increased it, this condition won't be equal. Okay, so this is the problem. So we have to do it for every s. That's we have to consider this number. Similar to insertion sort wala number, we have to consider this. So let's say the number we are on is num, which is a of I, right? A of I minus 1. And we have to compare if this is equals to a of I. If this number is equals to a of I, then we have if a of I is equals to this number, we'll increase it every time by this. Okay. So now let's check. Okay. So okay. So now this number. So now again when we'll compare, we'll check. Okay, this is equals. Sorry, this is num, right? This is equals to a of I. Yes, this is equals to a of I as well. So this is equal. So what we'll do is we'll take the current number as 2. We'll increase it by the previous number. So this will increase it to 4. So we'll do 4 minus 2. The current number was 2. The previous number was 3. So previous number was 3. 3 plus 1, we change it to 4. This changed to 4. Our count increased by 4 minus 2. So count increased by, count changed to 1 plus 2. That became 3. Okay. So count became 3. Next iteration, again, we increased, previous becomes a of I. So previous becomes 4. And next iteration, we increase I. So which again check, is this 2 numbers equal now? Is 2 equals to this number? Is 2 equals to this number? Yes, it is equal. So what we'll do is, we'll again try to run this, right? We'll again try to run this logic. We'll increase it. So we'll increase it by 1. Okay, so now we'll increase it again. So count becomes equal. So increase, we just check it, take this number is 2. So the current number is 2. The count, the previous number is 4, right? So we increase it by 1. The previous number we increase a of I by 1. It becomes 5. And then we take the count. So count is 3 plus 3. So that becomes 6. Okay, increase I. This time we'll increase it to 6, so we'll add 4, so this becomes 10. Right now, this is the first time this S is not equals to this. This is not equals to this. So we can say, okay, let's stop over here. So we'll stop over here. We'll just go. We'll take the previous number as A of I, which was anyway stored. Right. We'll go to the next number 3. Now the problem is we are comparing, starting with a new thing with 3, but we have already taken 3. 3 is not unique. 3 is now no more unique. We have already converted a number to 3, right?
तो सर आई थिंक इसके लिए हम एक चीज कर सकते हैं, जो ए ऑफ आई का जो प्रीवियस इंडेक्स है, जो कि जैसे कि 2 2 2 2 2 करके 5 2 है ना, तो आखिरी जो 2 है वो 6 में बदल गया। तो हम ये कंपेयर कर सकते हैं कि 3 लेस देन 6। अगर वो लेस है तो हम कुछ और करेंगे, अगर वो ऑलरेडी ग्रेटर है, मान लीजिए 3 की जगह पे 10 है ना,
already greater then we can do, right?
then
So
कुछ और कर सकते हैं।
yes. So if the current A of I is less than the previous number, then we have to increase it anyways, right? So if it is equal to the previous number, or if it is the current number, if the previous number is okay, if it is equal to them, or we can take it as if it is current number is less than the previous, or we can take it if we change this condition to this, if A of I is less than or equal to the previous number, then we have to increase it.
जो आखिरी जो नंबर है उसको उसमें 1 प्लस करके इसको इंक्रीज कर देंगे सर।
40. Okay, now we are getting 40. That's fine, right? So now what we are doing is, if the current this is less than the previous this, so we are just increasing it by previous plus 1, which is fine, right? So now this is giving us 40. Now see what we are doing, I just simply change the condition. So instead of doing this would work as the same way, right? This is less than the previous one, so it would work fine. Here what we are doing is, instead of checking it is equal, what I did was I compared this 3 with 6. So if 6 is like if A of I is less than equals to 6, which is yes, which is true, we'll enter inside this, we'll increase it. We'll increase it to 7. See, this is previous plus 1, so this will become 7. So we'll find out the delta 7 minus 3, which is 4. So which is fine. We'll add 4 to it. We'll add 4 to our result. It becomes 14, right? Next iteration again it is less, so we'll increase it to 8. Next iteration again it is less, we'll increase it to 9 and so on. Okay, let's validate whether it is working fine on the other logics. So let's check for this one. And when there are all equal, right? So this is the special case. And when it is let's try to submit this. कुछ तो edge case हो सकता है. Still I am not able to think of edge case, but there could be edge case. If number after 1 are in series, the previous is 1, that is it passed. Okay. So this is the order n solution. Anyways, we figured out order n. N square में तो हो ही जाता, right? N square में it was easy to figure out. चलो. Okay, let me explain this. Let's take edge cases that you are telling, right? We'll consider this, what is going to happen in this situation. So you have 1 3 3 3 3 3 3. So here we are starting with 3. Okay. So and the previous number is marked as 1. So okay, is 1 less than is current E of I is it less than the previous one? No, it is not less than, right? So 3 less than equals to 1. This is false. Will not enter into this. We'll mark this as the previous number. ये previous mark हो जाएगा. Next time we'll find this. Is this less than or equals to? Yes, it is less than or equals to the previous number. We'll enter into this. This cannot be the situation at the end 1 because we have sorted it, right? हमने sort कर दिया तो end में 1 नहीं आएगा. The 1 will move to the start. Okay, so you will not have a smaller number at the end, right? So that's why that's where the sorting is going to help us. Understood? I guess this requirement, this is required. This is required. When this condition doesn't match, we have to update the previous element. Okay, so let me explain this. I know this is a little bit going to be tricky to understand this. Okay, it was tricky for us to figure this logic out as well. Okay, let's check. Let's do a dry run. Okay, see, you can do this in n square, right? N square, and there is no problem. What you can do is you can just try to basically you can sort it. Take a sort to kar hi sakte hain. And then you can go through from the starting to this if you don't have. So let's say what is the n square logic, right? So let's say this is the array. So you sort this. This is your array going to be. You firstly start from here. Is this number present from the starting? Yes, it is. So whatever is the highest number that you got till here, just increase it by 1. So you got the highest number that you got till here was 2. So just increase it by 1. You make it as 3. So this change this to 3. Okay. So now this is 2, 3. You and accordingly update the count as well. Okay, you'll update the count. Next you got 2. So again you can start from the start and you can come till here and you'll check. Okay, we again got a 2. So what's the highest value that we got over here? 3. So we'll just increase it by 1. So it becomes 4. Okay. So you'll just change it to 4. Okay. Next for this number, you'll again do the same logic. You'll start from the starting. You'll go till here. You'll check what's the highest number that you got till here. It is 2. So since you found it, you increase it to 5. Okay. And same thing you do. So for example, if let's say the next number is here, the next number is 50. These numbers are not 3 but 50. Okay. So when you'll come to here, or let's say these are unique numbers. Okay, these are unique numbers. Let's say 50, 60, 80, and so on. Okay, largest. So when you'll increase it to 6. When you'll check over here, so for 50, you won't find any number to the previous of it. You don't have to increase it. For 60, you won't find any number that is present, which is equal to 60. So you don't increase. So this is n log n. So this is n log n for sorting, and then order n square for doing this work, which is brute force solution. Just compare whether it is present in the previous one or not. If it is present, you just increase the highest value plus 1, so that it becomes unique, right? And if it is not present, then it's fine, right? For example, 50 is not present, 60 is not present, 80 is not present. You don't do any operation. Okay. Now, this logic is n log n. Sorry, this is not order n. This is n log n. We require sorting as well. Yes. Now, what we are doing over here, say, I am just utilizing the information of sorting. Okay. So when you are sorting things now, it gives you a lot of other information apart from just sorting. See, what we are doing over here is check. So firstly, I assume that this is my previous number. Okay. Every time my previous number is going to increase by 1 every iteration, right? Every time I moves, my previous number becomes that. So for example, here we are increasing I am increasing changing the previous number. After every iteration in this, like when I increases from here, I am changing the previous number here. Okay. So whenever the I increase, my previous number will increase. That is taken care of. Okay. Let's say my I is equals to 1. First iteration. Do we need num? We don't need this number. Okay. Check. So what I have done over here is I have just compared. If this number is less than the previous number or equal to, if 2 is less than or equal to the previous number, yes, it is less than or equal to the previous number. It cannot be less than or equal to the previous number, because if it is equal, then it's duplicate, right? If it is less than, that means in the previous end, we might have some number which is equal to this. Okay, is array ke previously that scenario I'll explain just in a while for the next exam. So here it is equal, right? So equal is, so what we have to do is we are just storing this number current is equal to 2. Okay, we are changing this a of I to previous number plus 1. So what was the previous number? 2. So 2 plus 1, this becomes 3. Okay, and we find out the difference, a of I minus current. So a of I minus current is 2 minus 3. So count becomes 1. So we are doing count is equals to count plus 1. So count becomes 1. Previous number moves 1 iteration to the right. Previous number moves here. Okay. And I increases by 1. Okay. Okay. This is what happens in the first iteration. Anyone, any doubts over here? What we did in the first iteration of this while loop? Clear? Okay. Next iteration, what we are doing is we are checking, is this number less than the previous number? Is 2 less than equals to the previous number? Yes, it is less than, right? It is less than. Why do increase I in the while loop for this situation, right? See, so this can be a situation like this, right? So here it is less than, we can keep on going in, we can keep on changing this. Asha, let's validate, do we need to do this in the while loop? I'll come to that. If we can get rid of this and we can, so for example, here, if it was a 50, now we don't want to update anything. We don't want to do anything. If this logic should not run if this number is 50, next number is 50, right? So for such situation, we'll, we have written this while loop. So for example, if this number is 50 now none of this logic should run. We should simply skip this and we should simply go to the next number. Okay, and all these numbers will be definitely greater than 50 if this number is 50 because the array is sorted. Okay, sorted. So all these numbers are greater than 50, right? Yeah, 50, 80, wo situation I'm telling, 50, 80, 90, all of them are greater. Okay, not only one of them is greater, all of them are greater. So in that situation, I don't want to run this logic. Okay, so this logic should only run if I is less than the previous one, otherwise not. Okay, I'll check whether we can get rid of this while loop. There might be ways because we are doing initially the same thing, right? So okay, we can figure that out. Chalo. Let me first explain it using this way. So now a of I is this number. Our previous is 3. Okay, so I is equals to, now I became 2. The previous number is 3. Okay, now check. 2 is less than 3. So this value is a of 2 is having the value 2. 2 is less than 3. We enter inside. We store the current number is equals to 2. We update this to previous plus 1. So whatever was the previous number, we increased it by 1. So this becomes 4. Okay. Now we find out the delta. So this is 4 minus 2. So it becomes 1 plus 2, that is 3. Okay. We change the previous number. We update the previous number comes over here. And I increases by 1, right? So I increases by 1, I becomes 3. So previous number becomes 4, I becomes 3. I is 3, previous number is 4. Okay. Next iteration will compare again, right? Next iteration we are again comparing is 2 less than 4. See, now here you can observe this 2 is less than 4. What does this signify? If this number is less than 4, it means that this number is present in the left of it. Iske left mein jo numbers hai na, the numbers that are present in the left of it, this is present somewhere. Agar ye se chota hai to. Because we have increased them, right? We have reached by increasing it, and this number is still less than this. That means this is small. Agar ye 50 hota, then we would have not increased it. We would have broken the loop. We would have come down, and we would have just thought that 50 is our new number. Okay. But since this is not higher, okay, so this is present previously. So we'll increase it. This will become 5. We'll change this to 5. Okay, and we'll find out the delta is 3. So we'll add 3. So this becomes 6. Okay. Now I becomes 4. Previous number is at 5. So this will keep on doing increasing it. Okay. Let me tell you another scenario, right? For example, okay, every time it will be not same. So kuch to different ho sakta hai, right? So for example, this, if this is the situation, will we increase any of our numbers to 50 or 60? No, we will not. Check why this will not increase. So next iteration will increase this to 6. Okay, we'll increase this to 6. The previous will be over here. Okay, and I will go over here. So when I is over here, we'll check, is 6 less than 60? Sorry, is 50 less than 6? Sorry, is 50 less than equals to 6? This condition will not satisfy, will come out, and we'll just mark this as the previous number. So previous number will change to here and will not update this. So see, we did not increase it and we just jumped the previous number. So previous we jumped the value, but without increasing it, right? So that's what this if condition, this outer check is doing. This is jumping the previous value without increasing it. Right? So if you just suddenly get a higher number, so we'll increase it. So now every other number will be greater than this, right? So we'll not increase this to 7 to make it unique, or sorry, we'll not change it to 7 or something like that. We'll just increase it to the previous number plus 1. Right? If this number is equal, agar wo equal hoga then or less than hoga, then only increase it by 1. Right? Understood? How this cases is getting handled. How many of you got this logic? How many of you did not get any idea about it? You cannot remember this logic. There is no way you can remember this logic. It will take time to figure out that you can show me, right? I was struggling to figure this logic out, but somehow we got this. See, in situations like this, right? When you are sorting this array, right? So n square logic is fine, right? In this constant n square is also going to work, but most likely since there is a order and solution to this, you won't get n square approach to do, right? Here it was marked like here it was marked as medium, and this is like really difficult to figure this out. Okay, thoda difficult, so I'll accept that. Okay, but you can take the hint from here. What I told you earlier, remember when you have to actually perform any finite number of x increments, do we need to do that increments by, manually by +1 +1 +1? You don't, right? There should be some trick without doing that increments, you will be able to know what is the value that you will put there to it will become unique, right? So I just use that approach to figure this solution out. Right? There is some variables that we can remove from here, so it might look easy. So for example, the current, I don't know, if you move this up, down, so there might be something. Increasing I inside the while loop is needed. Increasing I inside the while loop is needed because if, let's say if we don't do this, let's check, right? If I is so instead of this, okay, let's do this. Instead of this, if we check if this is less than the previous number, will increase. We'll do this. Previous numbers becomes. I will increase it by 1. Previous number becomes a of I. Here also, if we are just putting previous number as a of I, we'll just put it outside instead of doing this, and we'll remove this. Okay, and we'll try to do this. If it is less than, let's run the code. Should be 3. So +1, it will increase there. This is less than, so we are increasing it anyways, not out of bounds. Yes, this is fine. Chalo, we cleaned it. Okay, happy. See, now it is easy, right? Ab thoda easy dikh raha hai, right? While loop now clean, clear and clean. See, same logic, right? Just that while loop was also increasing. I just moved it. I just removed that while loop. If condition, I changed it to if condition. So this will run only once, right? So this will run only once. Every time, like we have to just change previous to the A of I. So that is like something which we have to do. Even if we are increasing, if we are not increasing, right? So for example, this take 2 examples. Like for example, like this, 3, 3, 3, and for example, like this. Okay. So here we are not changing it. It is not satisfying the condition. Will not change this, but our previous should become equal to 50. So that is anyways happening. And in this situation, when we are updating the previous, so in that situation also, if for example, we are changing it to 3, so that situation also, it should be updated to the new A of I. So that it is happening. A of I minus, no, previous ke jagah mein we can write A of I minus 1. We can do that. We have changed it. Yes, that is like, again, yes, good suggestion. We can change it to I minus 1 since we have updated it, and we don't need this previous anymore then. So we'll remove this, and let's try to check this one. I guess so koi edge case to nahi hai na. There's something that we did not take. Okay, now this is also cleaner. Kuch to mistake nahi hai. I don't see anything right now. Yeah, okay. So this is also fine. Now it's easy to understand. It's becoming easier, right? Now clean it. This is what I did earlier, but this condition we did not check, right? Condition was not checking. I checked for equal to. I did not check for less than. Bas wahan pe wahi mistake that I think I did. Apart from that, it's fine, right? I minus. We can also remove C. Acha, let's think. C को कैसे remove कर सकते हैं? A of I is the current number, so we are updating it, right? So we cannot remove it. No, let's leave it, right? Let's leave it this. I guess this is cleaner. Okay. A of I minus 1. This is A of I minus 1 plus 1, and we move this statement to below it. Okay, chalo, yes, there is ways, right? So like you can do it. So see, just that the previous, so what's the use of previous? Previous is just storing the previous index value, right? वो तो I minus 1 को store कर रहा था. So for example, see this situation. So what we are doing is we are changing it to 2 and we are changing it to 3. So what is the previous pointing? Previous is pointing at 3. Now we'll change it to 4. So previous will point to 4. Right? But this is also getting updated in A of I. A of I में भी तो update कर रहे हैं ना. We are changing this in A of I. So we'll just instead of doing all of this work, we'll just use A of I minus 1. right? We are updating it in a of I. So in the next iteration, we'll just use a of I minus 1 instead of previous. So wherever previous was used, I just change it to I minus 1 because that is the place where a of previous is pointing to, and we have updated it, so that's not a problem. Okay, got it? Yes. बस ये less than कर देते उस time ना, we have written equals to, so our problem would have been solved. Just that for equal to we did so much मेहनत and then we realized this was the correct solution. ठीक है, sometimes you are going to the difficult routes and then you can clean your code. That becomes easier way to solve this. We can remove C as well, right? This is easy. This is so you can remove C as well. You can just need to I guess if you remove C, you need to do something like I minus 1 over here. A of I minus 1. Plus 1. Something like that you need to do, right? So this is like the current number. So current number is A of I. So now you have to do A of I minus 1 plus 1 minus A of I. So you have to do this. This is A of I minus 1 plus 1 minus A of I. So this is your and you need to do this after and you will do this. So ye ho jayega. I guess this is fine. So this is your A of I and this is A of I minus like the current A of I. And after you have done this, you just increase it by 1. Okay, so this is also correct, right? So this also submits. This is fine. There is no problem in this. Okay, I guess this is like little bit difficult for you to understand, for me to understand as well in the first course. So I'll keep it this way, using one variable to reduce. See, if you use one variable and increase your code readability, now I'll always prefer using this extra variable. 26 में we just increase the previous plus 1. So previous plus 1 ही करना था ना. The previous number, whatever is the previous number, will increase it by 1 plus 1. See, the goal of the code should not be like reduce the number of lines. It should be readable as well, right? कि ऐसा complicated code लिख दिया which is written in one line but not understandable. How will you explain that in interview, right? And interview में it will be equally difficult for you to explain your solution because interviewer is not going to submit your code and validate कि वो correct है, right? Here we have the submit button so we can validate our code is correct. But you have to explain it through all the examples that this is working for this example, and this example as well. Okay, so write codes that is easy for you to explain, right? At development phase as well, we don't consider one or two variables complexity. It should be easier to read because other developer is going to read it, he might use it. So it should be easy to read and understand. Understood, Mohammed? This one, why we did this? So it is nothing but the previous number plus 1. So for example, let's say this is this array, so we change this to 3. So what is this? This is previous 1 plus 1, so this will become 4. What is this? This is previous 1 plus 1, so this becomes 5. What is this? Previous 1 plus 1, so this becomes 6. What is this? Previous 1 plus 1, this becomes 7. Okay, that's what we are doing. We can do A of I plus 1, but see, you can do A of I plus 1, but here check what is going to happen. So this is going to become 3. A of I plus 1 is going to become 3. Here it is going to become 4. It is going to become 4. It is going to become 4. This should not be, this is not the array which is unique, right? 3 and 4s are repeated multiple times, so it is not unique. We need unique, right? We don't need, that's why the previous 1 plus 1 is definitely unique because previously everything is unique, and if we just add 1 to it, it will greater than the previous one is unique, but one greater than the current one might not be unique. Okay. Okay, so this is the easiest thing that we figured out. At the end, finally, this we are done with all the questions. Yeah, I want to discuss this one as well. There is the other question that was shared to me by mistake. This is also a good question. Okay, similar kind of question. Let's take this. Chalo, you want your lunch break? Quickly go and come back from your lunch break. Yes, this question was quickly take a lunch break, come back, we'll discuss the other questions. I also have a few other questions to discuss. Yeah. Okay, carpool, okay, we'll do that as well. Chalo, quickly come back first. Hello everyone, welcome back. I hope you all had your lunch. Chalo, let's continue. Okay, so let's discuss this one. I saw this question, right? And this is like, and the question that we discussed just now, this is similar to that, right? So here, but you are allowed to decrease as well. Okay, so here you are allowed to perform a decrease operation as well. So very slight variation. Now you have to think of the solution. Okay, so see, what is this telling? That we are given n births, okay, and n passengers in the train. So there are n births and n passengers in the train. Now you have to you can either change the passengers at j by increasing or decreasing it by 1, right? Every ith passenger you can either increase or decrease by 1. So and you have to basically make it equal to some berth so that you will that passenger will have one berth to travel. So for example, let me explain you using this example. So let's take this one, this particular 5, 2, 6, and the second array is this. So the first one is the berth and second one is the no. So first one is the berth. So this is the berth and this is the passengers. So here you can either increase or decrease the passenger by 1, and you have to make it equal to some berth. So for example, if I increase this 4 by 1, so it will become 5, which is equal to this berth. Okay. If I decrease this 3 by 1, so it will become 2, which is equal to this berth. If I increase it by 1, it will equal to 6, which is this berth. So every passenger now has a berth. Now, how many increase or decrease operations we perform? So here we increase it by 1. Here we decrease it by 1. Here we increase it by 1. So total we performed 3. Okay. 3 increment or decrement operations. Right?
सर क्वेश्चन एक बार और समझा देंगे, थोड़ा समझ नहीं आया.
So there are two things that's given to you. One is the berth, one is the passengers. Okay, 2 arrays. So first is the berth. This is the berth numbers. These are the passenger numbers. So now basically you have to you can increase or decrease the passenger. Passenger को हम +1 से increase या +1 से decrease कर सकते हैं. ठीक है. Either you can increase the passenger by 1, like 4 + 1 it becomes 5. You can increase this to again by +1 becomes 6. Similarly, जो हमने पहले करा था, right? We can either increase it or decrease it by 1. And we have to ultimately make it equal to some berth. So for example, in this example, what I told that we will increase this passenger by 1. So it will become 5. So it will got a berth, right? Which is this. Okay. So this passenger will go to this particular berth. Now we'll decrease this by 1. So this passenger will go to this particular berth. Now we'll increase it this by 1. This passenger will go to this particular berth, which is this. Right. Now let's take the second example, which is a larger array. Okay, this example. Let's take this one. So here what we can do is, so we have this 1, 8, 5, and take this one. This is 4, 1, 3, 2, 8. Okay. So here again we can increase or decrease it by 1. So we can let's say what it has told, will increase this by 1, so it will become 5. So this passenger has got a berth. Okay. 4 में तो कोई berth नहीं है. We could have decreased it by 1, or we could have option to increase it by 1. So let's say we are choosing increase it by 1, so it becomes 5. So if this passenger got allocated this particular berth, so this passenger, this berth is allocated. Now these are the berths remaining, these are the passengers. So 1 already has a berth, so we'll allocate this. 3 already has a berth, so let's say we'll allocate this. Okay. 2 or 2 there is no berth equals to 2, so we'll increase it to something, like we can increase it to 6 or we can increase it to 8. So let's increase it to 6. So this will become 6. Because we increase it by 4, and 8 will increase. We'll just keep it as it is. Okay. So these this value, and this value did not change. These two values changed. So this changed by 1. This changed by 4. So total 5. So at max, at 5 increments or 5 increments or decrements, we can increase or decrease it. Yes, Adnan, that's the correct answer. Okay, understood now. So here you are allowed to increase or decrease as well, and there can be a lot of ways you can make this passengers equals to the berths. You have to tell the minimum number of increment or decrement that you will need to perform to make it equal. Okay, हमें minimum बताना है. Okay, minimum number of steps required to make it equal. Now you have to count those operations. You have to count those operations. How many operations you did to make it equal. Right? So for example, if you changed 4 to 6, or let's say you change 4 to 6, so you did 2 operations. You changed 1 to 8, you did 7 operations. So that's what you have to count. Okay. Anyone getting any idea? We just did a similar question. अब थोड़ा सा कुछ चमक रहा है उससे. हाँ, yes. Yes. Yes, Anas, that's the correct answer. Or I don't know how to spell your name. How do you spell it, Mohammed?
Sir, it's Anas.
Anas. Mohammed Anas. Okay, that's a unique name. I saw this name for the first time. Yeah. So that's what does it mean?
It's something related to loving kind of thing.
Okay.
I don't know exact.
Okay. That looked great. Okay. So see, the easiest solution is these are the berths and these are the passengers, right? So see, the easiest solution is you allocate the passenger to its nearest berth, right? Whatever berth number is nearest to it, right? So we have a lot of passengers, we have a lot of berths. For example, consider this. So
सर हम शॉर्ट करके तो डिफरेंस निकाल सकते हैं.
right. So we'll sort. So we'll find out the nearest berth to that passenger. So for example, if you sort this array, you'll get 1, 3, 5, 6, 8. And if you sort the second array, you'll get 1, 2, 3, 4, 8. Right. Now the nearest berth, both arrays has to be of same size, right? Because like both arrays are given of same size because the berths are equal to the number of passengers. If that is different, then that's a different question, and that is then it would be a little bit difficult to figure that out. Difficult, you have to ignore some berth, right? Or if you have some, so if there are extra berths, you might need to ignore. So that can be also one variation of the question. Okay. Now here, luckily it is equal. We don't have to do that logic. So let's say we sort, right? So the nearest berth to the passenger 1 is this. So in terms of number, right? In terms of number, if this is passenger number 1, so the nearest berth to its value is 1. So we'll not do anything. Nearest berth to this one is 3. If you change it to 5 or 6 or 8, you'll require more number of additions or increments or decrements. But if you just change it to 3, it will be easily done. Right? So we'll increase it by 1. Okay. Here we'll increase it by 2. We'll increase it by 2, and this we won't increase. So 2 plus 2 plus 4 plus 1 5. Here the explanation that was given for this particular example, I guess had a different approach. Yes, so it had a different approach. It has told us in some different way. So and generally tells you in this different way how can you get the same result, so that you keep on trying to do this. And instead there can be some other way to do this. It is also getting 5. Now it doesn't matter how we are getting 5. The end result should be minimum, right? So there can be other ways also to get 5 in the same scenario. This is also giving 5, which is minimum, right? So here what we are doing is we are just sorting both the arrays. Now every passenger will try to equate it to its nearest berth, right? Usko nearest berth ke sath equate karna hai. If it is not equal, just try to add, subtract, whatever you want to do, will equate it, right? If you do it to any other berth to the right or to the left of it, the difference would be higher. But if you do it with the same berth, the difference would be same. Difference would be minimum. Okay, that's it. This is the solution for this problem. So you just need to apply sorting on both the arrays dot sort B, and you do arrays dot sort P. Okay, and we just need to traverse through one of just take any one of the size. Both the size are equal. And you just need to find out their difference. So you can use math.absolute because the difference might be negative. So you can use differences math.abs. If the difference is negative, will increase. If the difference is negative, will increase. If the difference is positive, will decrease, or something like that. P of I minus P of I is the difference, and finally we'll count. Count plus is equals to T. Done. At the end, we can return this result. Count. That's it. If I do this, run this, we should be seeing 5. And if we submit, it should be fine. and this is marked even as easy one. Understood? Anyone, any doubts over here? So we just sorted it. The nearest word to the passenger number would be equals to the same corresponding element which is there in the sorted array. Neither to the left, neither to the right one. This is way easier than the previous one. Yes. That's why this is marked as easy. The other one was marked as medium, right? So this was marked as medium, and this is marked as easy. Now see, there is lot of variations of this same question. Okay. One thing that you can so keep in mind from here, in any question, if you ever see something like this, right, you increase or decrease it by 1 and you can make it equal, right? So there is another variation of the question where it has asked you, you are given an array of numbers, you can increase or decrease every number by +1 or -1. Okay. And you have to make the entire array equal. Okay. You have to make the entire array equal. Okay, that is also one variation. You can increase or decrease every number by 1, and finally you have to make the entire array equal. What will you do? Okay. So here it has asked you, how will you allocate the do this allocation, right? Carpool. Which question is that? Okay. Now similarly, there are like lot of variations of this question. The one thing that you can remember from this is you can use sorting to somehow figure this logic out. Sorting might make this easy. It's not necessary that always you will need to sort. So aisa nahi karna hai ki if you see this and you just start by sorting. Okay. Sorting might work in a lot of questions, but might not on every question. So sorting is one thing that you can keep in mind. Sorting is something which you can do in this kind of question. Second is you don't have to perform +1 -1 increments yourself. There is some way to do it, and most of the time, 90% of the time, the complexity that you would get is order n. These questions are doable in order n. You don't need order n square complexity or any additional space. These questions can be simply solved in order n. Okay, so these are few things that you can keep in mind. So sorting is something that can help. Complexity most likely could be done in order n. So if you are thinking of n square, it might get accepted in the platform, but in case of interviews, you need to think there would be a order n solution definitely. Okay. If you don't get any idea of order n, then you can explain the order n square solution. And you don't need to perform this operation. This is something which I already told you, right? If you ever see something like +1 -1 or increase by any finite numbers of times, you don't have to necessarily perform that operation. Your questions can be solved without performing those operations. You can still get the result. Okay. Simply sorting, yes, sorting is something which will help, right? Most of the time sorting works in this question. So yes, sorting is something that you can use. Okay, let's take carpooling. So now Uber has removed carpooling after COVID. There used to be a carpool before it. Yeah. So what is carpooling? So basically, there is a car with K seats and the vehicle drives seats. You cannot turn around and drive west. Okay. Obviously, you are given the integer capacity and the array trips, where trips of I is equals to passenger I from I to I. Okay. Indicates the trip from passenger I to this and the locations to pick them and drop them off from respectively. Locations are given in the number of kilometers due east and then car's initial location. Return true if possible if possible to pick up and drop all passengers from the given trips are false. So for example, passengers I. So this is the passenger number, and car picks 2 people at the starting point 1 and starting point 3. The car picks 3 people. And the output of the car is 2 and deliver all the people at the desired location. So there are 2 people who want to go from 1 to 5. There are 3 people who want to go from 3 to 7. The total capacity of the car is 5. Okay. So this is the question that I got in my Microsoft interview. Okay. So not exactly this wordings. The wordings were different, but I'll tell you this is a classic question of like this is a platform allocation or carpooling. These all questions are a classic example of allocation of time. Okay, time allocation of this. So this is if you struggled on this question, great, because this is a question that I got in my interview rounds, and that was on-site. So that was like in the fourth round of interview. Okay, fourth round of interview. Right. Okay, so let me explain you this. So there is other variations of this question. I'll tell you what are the other variations of this. So let me tell the question that I got. Similar, exact same question. So basically you are given the start time and end time of a train, right? So let's say you are a platform master. Okay, you are a master of a platform. Your responsibility is to allocate trains to the particular platform. So there are multiple platforms in your station. So there are, let's say, 1, 2, 3. There are 3 platforms in your station. Okay. And what you are asked to do is you are asked to allocate trains to these platforms. Okay, so there can be one train. So let's say you're given what is the thing that is given to you as input. So you're given the arrival time and departure time of the train. Okay, so you're given, let's say the arrival time is 9 and the departure time is 11. Your arrival time is, let's say 10 and the departure time is, let's say 4. Your arrival time is, let's say 8 and the departure time is, let's say 7. Sorry, 7, it cannot be 7. It is 9. Okay, your arrival time is, let's say okay, it's cannot be 10, 14. Okay, its arrival time is, let's say 12 and the departure time is, let's say 18. Okay, so you're given the arrivals and departure times. You have what you have, and you are given for n trains, right? What you have to tell is whether you will be able to allocate these platforms to the train, whether 3 platforms would be sufficient to allocate it to the trains, or you need more platforms, yes or no, whether this allocation would be possible or not. So for example, let's say the first train that arrives is at 8, right? So you put the platform, you give platform P1 to this train that arrives at 8. Now this platform is blocked till 9. You cannot use it for if any other train comes at, let's say 8:30 and it departs at 12:30. You cannot give this train the same platform because this train is parked at this particular platform and it will depart at 9. So you need to use the P2 platform to give it to this particular train. Okay. Next, the next train comes at 9. So at 9, this platform gets empty. This platform is occupied. So you can give this platform to this train, right? So this one goes to P1. You give this to P1 and this to P2. Okay. Finally, like you are remaining with 2 trains. So this train that you gave it P1, this will depart at 11. So this is blocked. The platform that you P2 is given to this is also blocked. When this train comes at 10, you don't have P1 and P2, both of them are blocked. This train is parked as P1, this train is parked as P2. So you don't have the P1 and P2 platforms empty. So you'll give this train the platform P3, the third platform. Okay. Now at 12, so by 12, this platform will get vacant. This platform will get vacant and you can reuse this platform. And when this train comes at 12, you can give this train the platform P1. Okay. So, and there are no more trains. So every train, it is possible to allocate it by using 3 platforms, right? If you have 3 platforms, you can use it to allocate to the trains and should be fine. So this question is a very famous question known as minimum number of platforms, right? You don't have to print yes or no. So it is simply, the question is asks you what is the minimum number of platforms that you require for if the train's arrivals and departure times are like this, such that you can give 1 platform to every train. Okay, you can give at least 1 platform to every train. What is the minimum number of platforms you require in the station? If the arrival and departure times of the trains are like this, what's the minimum number of platform you require so that no train needs to wait or no train won't have a platform to get parked? Understood? And this is also similar question. The logic is going to be same. Okay. So I know it looks like it's not related, but here I'll tell you how it is related. So here, so this is not asked you the minimum number of platforms. It has asked you yes or no. So like this question is this variation on this. It has given you the number of platforms. The platforms is given that you have 3 platforms. Whether you have to tell whether you can use these 3 platforms to park the trains, yes or no. Here the same question is varied. Instead of platforms, you have the car capacity. So this is the nothing but the platforms. This is nothing but the platforms. Okay. And these 2 arrays are nothing but the timings. Right? Instead of time, you are given the distance that this is moving from distance 1 to 5. It should also be moving from 3 to 7 or in the towards east, right? If it is moving something in negative or something in the opposite direction, you cannot take them in the carpool. Right? So for example, if one passenger is moving from 1 to 5 and someone else is moving from, let's say, -3 to -2. So -2 to -3, something like that. So they are going in complete opposite direction. You cannot pick them up, right? So you cannot do them in a carpool. So that's something which it has changed. Okay, but that's it. I guess this is the capacity and this is the like the timing. See, it is related to timing. So we'll figure that out. Okay, I'll not give you the solution to this. You can think, you can struggle. This is one question where you should struggle, but I'll give you how you can solve this. Okay. So see what it has asked, that it has given you the capacity, right? Let's check whether it can be negative. From to 2, this is the given thing. So I guess from to 2 you can always pick up. Is there any scenario indicates that TI passenger and locations to pick them up and drop them off from I to 2I? So your pickup location is I and this is the drop location. The number of the locations are given in the number of kilometer due each and the car's initial location. So it has made it even simpler. No timings, no direction. So the car is initially at 0. Let's assume, and your directions are given in, like, for example, 1 2 3. Okay, or 3 to 5 or 1 to 8, something like that. Your directions will be given. Okay. Return to if it is possible to pick up and drop off all passengers at the given trips, otherwise false. So you just have to validate whether these the numbers that you have. So you will assume, let's assume we can, all of them are positive, so all of them can be picked up. We just have to ensure that we do not break the capacity while picking the passengers up. So for example, when so this is like the first, which one we will be picking first? We'll be picking this one first, right? So if we pick this one first, we get 2 passengers. Our remaining capacity is 3. Okay. Next we are at 3. Next when the passengers we see at 3, we have not dropped them off right now. हमने उनको drop off नहीं करा. Same like the train is parked and the other train has arrived. We cannot park the train on the same station, right? So we cannot, we have not dropped them off. So we have to adjust them in the current car capacity itself. So current car capacity, remaining capacity was 3. We have 3 more passengers, so the capacity changed to 0. And we can pick all of them. So firstly we drop these 2 and then we drop these 3. So finally it's 2. Okay. Okay. So because we can pick all of them up and we can drop all of them. Acha. Let's check this one. Can we do it over here? So we'll pick the passenger at 1 first. We are starting from 0. We are moving towards 1, 5, 7, 1, 3, 5, 7, and so on. So we'll pick 1 passenger at 1 first. So 1 will pick 2 passengers. Okay. We have to drop them at 5. So we'll have to drop them at 5. Okay. But at 3, we saw 3 more passengers. So we picked them up. Right? Can we pick these 3 up? No. The remaining capacity is 2 because the car capacity is right now 4. So the remaining capacity is 2. So we cannot pick these 3 up. So we can only travel each. So if we go to here, reach 5, we would have skipped these 3 passengers. So we cannot pick them up. So there is no way we can pick them up. So it is false. Understood? Why it is true, false? First, tell me, did you understand the question? Anyone, any doubts on this? What this question is? Question samajh aaya, logic leave aside, right? Tell me, did you understand the question? So you have to basically tell whether you can pick all the passengers up without breaking the capacity. Okay. So let's say this is your car. Okay, 0. Okay, consider you are the driver of the car. You are driving the car. There is a person which is standing at 1. There are persons who are standing at 3. There are persons which are standing at 5. There are persons which are standing at 7. Okay, let's say there is forgot about when we'll drop them. Let's consider like all of them drops are very high. Okay. So there is 2 persons over here. There is 3 persons over here. There is 5 persons over here. There is 2 persons over here. Okay. Let's say you started from here. Okay. You started traveling from 0. So you got all these are the passengers that you have to pick up. Okay. So now let's say your car capacity is 6. Okay. So can you pick all of them up and you can drop them? Can you drop them? So let's say the drop locations of these are this. So the drop, so for the first one, for the 1, the drop is let's say 9. For 2, the drop, for 3, the drop is 10. For 5, the drop is 11. For 7, the drop is, let's say, 13. Okay. So this is a drop for 1. This is the drop for 3. This is the drop for 5. And this is the drop for 7. Okay. What you have to tell is whether you will be able to pick up all of them and drop all of them. Okay. And given your car capacity is 6. So let's say we started from here. We reached here. We saw 2 passengers. So we picked them up into our car. Okay. So this is our car. Okay. This is us driving the car. Okay. And here we had capacity. So we had capacity for 6 people. Okay. So we picked the first 2 people. We put them into the car. My car capacity decreased to, so it was 6. So now there are 2 people which are sitting. So the car capacity, remaining capacity is 4. Okay, now we have capacity for 4 more people to sit in the car. Okay, we happily drove, right? We reached over here. Now, when we came over here, we saw 3 more passengers. So, okay, let's pick them up also. So we picked 3 more passengers into the car. Okay, now my car capacity, remaining capacity is 1. We can only allow 1 more passenger to sit into the car. Okay, next we reached over here. We saw 5 people standing over here. 5 people are there. Now, can we pick them up? No, we cannot do a partial pick. You can you can pick all of them, right? You need to pick all of them, and their drop is somewhere there. You cannot drop any one of them because all of their drops is like one should be dropped over here. The 3 people that you pick should be dropped over here. So you cannot pick this 5 people, and you have to like drive past. So if there is a situation, right? If there is a situation where you cannot pick these people up, so you have to return false. Basically, you cannot pick all of them and drop them to their respective locations. So you need to you cannot pick them up. Okay. Now you'll say, sir, this will always happen. We can simply count this number of pickups, and if it is greater than the capacity, then we cannot pick them up, right? No, it's not the situation, right? You cannot count the capacity and you can say we'll check whether it is equal or not. What if there is a situation like you have to drop a few of them before, right? So for example, this one's drop is not over here and this 3's drop is not over here. They are dropped and both of them drops are at 4. Here, 1 will also be dropped over here, 3 passengers will be dropped over here. So when you reach this 4, you'll drop all of them. Okay, so you'll drop all of them. So all of them were dropped. Okay, and now you're moving towards east again. So you saw 5 more people. You say, oh, let me pick up all the 5 people. So you picked up all the 5 people. Okay, now you're happily driving. Okay, so now you dropped them off. Okay, now you check over here. Now you reach 7. These 5 people will be dropped at 11. So you again see 2 more people. So now you cannot pick these 2 more people. So still it is false. But if this 5 people could be dropped at 6, then you could pick 7 as well, and you can drop them off. Got the idea? So if this 5 people's drop location was at 6, now you can complete this, right? So if this 5 people can be dropped at 6, so now at 7, you'll drop them. At 7, you'll pick 2 more people. You'll drop them at 13. Okay. Acha, any suggestions, any ideas that you think बहुत easy? The solution is very easy. Just think. Think and tell. Okay, take your time. Take a minute to think and then tell the solution. Think what should be the solution. Yes, that's the correct. Pickup will increase the count, drop will decrease the count. If the count becomes greater than the capacity, it's false. Okay. Now, just before that, you need to do something. Okay. The given pickups and drops won't be in the sorted order. So if you follow, so how will you check, right? So for example, you have 1, 5 pickup drop, then you have 3, 7, then you have 8, 10, and then you have 2, 4, and then you have 3, 6. How will you? So you'll first pick up 1, 5, and then you'll say 3, 7. What will you do? You cannot do it in this way. You have to sort the array, but how will you sort? Right? You have to sort the array. There are 3 things, right? How will you sort? So forget about passenger I, right? Forget about the passenger count. There are third parameter is passenger count, right? So that is also important. So how will you sort? So will you sort? So you have 3 things. There can be 2 passenger, 3 passenger, 5 passenger, 1 passenger, 3 passenger over here. How will you sort? What's the sorting condition? No idea. Any idea? कोई भी idea नहीं लग रहा. First element is the capacity. Will we sort based on the capacity? No, we don't need to merge it. So actually you have to sort this array based on the starting time. You have to sort this array based on the start location. This is the parameter on which you will be sorting this. Check. So if you sort this based on this, your final array would look like this, right? 1, 2, 4, 3, 3. If they are, there is also one more thing. If they are equal, right? For example, here they are equal. So you'll pick the so your sorted array should have the ones which will be dropped first, right? So the drop location will be first. You will be picking them first. Okay. And then finally 5, 8, 10. Now, why did I do this? Just follow this one, right? I just drew that. अच्छा था drawing बनाया मैंने, right? So we are moving in this direction, right? Our car is moving in this direction. Our car is moving in this direction, right? Okay. So we are moving in this direction. So starting from east and going to west, which people will see first? The people whose pickup time is prior, right? Who will be first in this road? I'll see them first. So whose pickup will be 1, pickup will be 2, pickup will be 3. I'll see them first compared to the people who will be pickup will be 10, 11, 12. So I cannot skip any one of them. So I have to pick them up, right? So that's why sorting them based on their pickup time is the best thing. Yes, I'm very bad at drawing. Yes. Okay. So understood. I'm very bad at drawing and my writing is also deteriorating every day. It is bad now. It has become worse. Clear? Yes, no. So you will need to sort it based on this time. If the times are equal, you need to compare departure time, sort it based on that. And then finally, this is your array. Your array should look like this after sorting. And then you just need to check whether you pick them up. Okay. Once you pick them up, you just can take 2-pointer approach, right? You pick them up, you pick them. So whatever departure times comes, right? Whoever departure time is coming, you will just depart them. Okay. Now I gave you enough hints. Can you write this logic? I know it is going to take time, but I want you all to take time. I don't want to give the solution because this is a question that is very frequently asked in interviews. Minimum platforms. This carpool is again carpool is again an example of that. So you can search for a question known as minimum platforms. If you solve this one, try to solve that question as well. I guess wo hoga hi total mein. So if you search for that, minimum platforms. No, it's not there. It might be there with some other name. You can search for like a classic. It's a classic question if you search for minimum platforms. It is there. It should be there because it is a very common one. Okay, this is the question, I guess. No. This one, right? Yeah, Geeks for Geeks. You can look for this. The same question you'll find out in this minimum number of platforms required for bus or station. Yes. So this is the arrival and departure time for each train that is given to you. And what you have to do is how you have to tell what's the minimum number of platforms you require so that you can park all of them. Okay. Yeah, just that you have so basically if I change this question to little bit to ask this, that if you are given this number of people and you are given the pickup and drop locations, you have to tell what's the minimum capacity of the car that you should have so that you can pick all of them up. Okay. So that's the same logic here, just that you have to calculate this. So same thing that we did over here, right? जो भी हमने करा अभी, right? Instead of telling that if this is okay, this is something exceeding my capacity, then I cannot pick it. You just increase it, right? Whatever is the maximum capacity that you will get at any point, that is your result. Whatever is the maximum number of passengers that is sitting at your car at any point, that is the maximum capacity. That is the minimum capacity that you should have, so that you can pick all of them up and you should be able to drop all of them. Understood? Okay. Now try this question. Okay, take your time. If you are struggling, that's fine. Okay. Then it will become busful. Yes, it would. It might become busful, right? But doing that. Yes. Make the number of distinct characters equal. So you're given a 0 index string, word 1, word 2. The move consists of choosing two indexes I and j. So I 0 to I word length and 0 to j word to dot length. Okay. I j will increase, decrease it. Swapping a of I word of I with word 2 of j. Return true if it is possible to get the number of distinct characters in word 1 and word 2 to be exactly one move. Possible to get the number of distinct characters in word 1 and word 2 to be equal and exactly otherwise false. So for example, if we any pair of swaps will not yield two distinct characters in the first string and one in the second string. Here it has told that we swap index 2 with the first string of the first string with index 0 of the second string, index 0, 1, 2. So 2 of the first string with index 0. So it will become CAB and CAB. AB, AC, and CAB, which both acha. The number of distinct characters should be equal. Okay, that's what it has asked. Okay, so it has asked basically, can you create it in such a way that can you possibly perform one swap to get the number of distinct characters to be equal? Okay. So what this question is told, consider this example right here. What it has asked that we can you swap move one character from this to this particular string, and the number of distinct character can be equal. So what is the number of distinct character over here? 3. How many distinct character do you have over here? 2, right? So if you move C from here to here and place A instead of it, so the number of distinct character over here will become 3, and the number of distinct character in the second string will also become 3. So now you have equal number of distinct characters. Okay. In this example as well, where you have 5 distinct character, here you have 5 distinct character. So you don't need to swap anything. Your count of distinct character is 5, which is 2, right? So if it is initially 2, you don't is it possible to perform exactly one move with exactly one move? Return false. Exactly one move. This is performing in 0 move. If you swap it, okay, no matter whichever character you swap, it will be still having 5 distinct characters, this one and this one. So it is again fine. Okay, let's think through this. How will you do it? You count the frequency. So like that's just the hashing technique that we have, like array, you can store the frequency of each character. Now the characters whose frequency are same. So you okay. So first we have to count how many distinct characters are over here, how many distinct characters are over here, right? If the difference is more than 1, right? So for example, if that more than 2, if the difference of characters is more than 2, like 3, 4, or 5, this has like 5 distinct character and this has 1 distinct character. You cannot change it in any way. Okay, you cannot change it in any way. See this. So for example, if the first string has 5 distinct characters and second string has 2 distinct characters, difference is 3 or greater than 3, then you cannot change it. So for example, consider this A, B, C, D, E, and there is A, B. So no matter whatever you do, you cannot change, you cannot make this as 4 or this as 4, this as 3 or this as 3. That cannot be done by exactly one swap. Okay, so that is not possible. So if your difference in distinct character, you can count the distinct character in this and distinct character in this. If it is greater than or equals to 3, or I guess even 2, if it is 5, 2 ke liye ho sakta hai kya? 5, 3. So this is A, B, C, D, E. This is A, B, C. So you will swap this. So this will become A, B, C, C, E, 4, A, B, C. This will become 4, this will become 3. No. If it is if it is 2 or if it is greater than 1, then you can just return false, right? If the difference in distinct characters is this is 5 and this is 3, you can simply difference is 2, so that case also you cannot do. If the difference is 1 or 0, then only you can do, right? If the delta is 1 or 0, then only this swap is possible. If it is 5 and it is 4, or if it is 5 and this is 5, then it is possible. So if it is 5, it is 5. So you just need to validate. You can just move one character from this string to the other string. There might be some edge cases, like for example, E and you have A, B, C, D, same characters. So you can swap the same character. Same character, we can move from here to here if it is same, and if it is different, right? You can pick any different character. So if it is equal, I guess it is possible. There is no cases which might come over here. You just need to validate. If this has 5, this has 4 distinct characters, then you have to check whether is there any common character over here. So for example, let's say the first string has 5, second string has 4. So A, B, C, D, E, and this has A, B, C, D. Or let's say it doesn't have anything as common. Okay. Let's say this is E, F, G, H. Okay. So you don't have any characters in here that is not common over here. That is common over here, right? So the characters in the first string does not any character in the first string is not present in the second. Actually, E is present. So let's take this to F, G, H, I. Let's change it to this. Okay. So any character in the first string is not present in the second string, right? Now in this situation, no matter whatever character you swap this string with, right? Whichever character you swap it with, this will still have 5 in distinct characters, and this will have 4 distinct characters. So you cannot make them equal. If there is even one character as same, right? If this has E, okay, and you swap it with some character like D, so this will reduce the number of unique characters will reduce to 4, and here the number of unique characters will increase by 1. Got it? So this is the case where you can you should return true, you can swap it. And the other case, if all the characters are distinct, no matter whichever so if all of them are distinct, so you can just swap any one of them and it will become equal, right? So all of them are distinct, so you can so example here all of them are distinct, you swap it. If all of them are same, if at least one of them is same, then you can do it. And if consider this situation, A, B, C, D, this is present and this is present. Now, no matter, can you do it? If you can change this E with D, you can actually do it in this situation as well. So this will become A, B, C, E, which is true, and this will A, B, C, D, D. In all the situations you can make, right? If there is one common, if the entire string is common, and if there is no common character, then also you can do it. So I guess this should be the scenario. If the distinct character count is difference is equals to 1 or less than 1, you can do it. If it is greater than 1, you cannot do it. Simple. Yes. The distinct character, you have to just count the distinct characters in both the strings. If the distinct character count is equals to 1, you can do it. Otherwise, you cannot do it. Okay. Try using this approach, should be fine. You can use 256 size array because I don't think it has told. It has not told anything about lowercase, uppercase, or anything. So you can use a 256 size array for the safety, like for better, right? So it has told, right? यहाँ पे बता दिया only lowercase English alphabet, so you can use 26 as well. Okay. So lowercase English alphabet it has told, so you can use 26 minus A, right? A as a character, so that will work fine. Or the rest 256 is anyways in all situations going to work fine. Okay. Clear? Okay, carpooling. Okay, try to do this one. If you solve this one, check the minimum number of platforms वाला question. ऐसा logic build कैसे होगा? See, देखो यहाँ पे ना you can do observations, right? This will gradually happen with time, right? So you can solve more and more questions, and they'll okay. So for example, see here this carpool question. As soon as I saw it, I read it, I understood that this is similar kind of that platform allocation. You will start to relate it. That relation you will start to make it. Okay, this is related somehow similar to that question. Here distinct character. See, one thing that you can keep in mind is in that string wala case na, distinct character you just can count everything, how many times each character is present, and that might result in something. So here it has told exactly one swap. So हम एक swap में कर सकते हैं नहीं कर सकते, that we can think, right? In which strings we can take do and which strings we cannot, right? So try to take those examples. Pehले examples lo, write the examples lo, try to test your logic that you are thinking. Take examples, test the logic, check for multiple scenarios, right? I checked for multiple scenarios like A, B, C, D, E. If they are equal, if they are not equal, so what is going to happen? ऐसे check करो, right? जैसे for example, this is 5, this is 4. So this is one case, this is one case, or this is one case, or right? So check for all the scenarios, and if you are able to do it, then you conclude, okay, my approach is fine. We just need to count the distinct characters. If you are not able to do it, right? If you are not able to do in using one of the swaps in any particular scenario, कोई एक case में नहीं हो रहा, then you need to write कि अच्छा, if the difference is less than equals to 1, then this is something which I have to check. Otherwise, if it is greater than 1, then we cannot do. वो तो नहीं हो सकता. If the distinct count is greater than 1, if it is less than 1, then these are the cases. Luckily, here there is no such case that's coming out. So we can just need to check greater than 1, less than 1, and we can return. हाँ, अगर एक स्वैप की लिमिट हटा दे तो then it would be like then I guess it would ask you how many swaps, what is the minimum number of swaps you need to do to make the distinct count as equal. Okay, so I guess like let's say you found out the first string has 5 characters or 7 characters. Okay, 7 distinct and second string has 3. First में 5 है, second में 3 है. So you might end up somewhere in between. Like for example, you move one distinct character to here such that it is common. So यहाँ पे the count will decrease by moving one character from here to here, and here it will increase. And if like there can be scenarios where you cannot convert it in any ways by swap. For example, in this situation you cannot convert it. No matter whichever character you move from here to here, the count will remain 3, and here the count will remain 7. Sorry, 5. F E. No matter which 2 characters you swap, no matter how many characters you swap, the distinct count is going to remain 7 over here, and here it is going to remain 3. So here you cannot do, right? So that will be the situation. Whether you can do, if you cannot do, return -1 or something. And if it is possible to do, right? If it is possible to do, for example, let's say this is of length 4. So let's say this is of length 5, and here it is of length 3, A, B, C. So can we make it 3? Yes, we can actually. So we have to just swap it with the character that is already, B is already present. So we'll bring B over here. So this is the logic that I can think of. We'll make it not C, sorry. We'll bring B to the here, and this will make it D. So this is still 3, but this changed to 4. Right? So the distinct character changed here to 4, but this is still 3. Right? And the next iteration, so this we changed, right? So this we changed. So let's say this is D and this is B. We changed to A, B, C, B, E, and we changed it to A, B, D, C. And now we can change for C. So we can change C, A, B, C, D, C, and here A, D, E. So here it will become 3, and here it is 3. Right? So this is the logic that we can think of. So we will swap the characters such that the character is already present over here. So the like distinct count does not increase over here in the higher string, and and in the lower string the distinct count remains same, right? Something like that. You cannot increase the distinct count, or you might also in a situation increase the distinct count in this lower string value string. So that is something which you can do, right? And this would give you the minimum number of operations. There will be few if else checks and a little bit code that you need to write to perform this. But yeah, this can be your logic. See, logic think कर लो पहले for the smaller one. Don't think in terms of code. कि how will we write this? ये कैसे check होगा? ठीक है. So for example, here I told you that this is the logic. Now if I tell you to think it in terms of code, it is so complicated. How will we figure out कि this character is already present? So we need to check is there some character which is already present over here, present in this, and then we'll swap it with something that is unique to this string, right? So much amount of work. But for small strings, your brain can think this solution. You don't need the machine for this solution, right? So you can trust your brain, you can trust yourself. You can solve this for small strings. For large strings, we might not be able to solve. It might take a lot of time. But for small strings like this, we can solve it. Logic is going to remain same. For large strings, the logic is going to remain same. Some small strings के लिए solve कर लेते खुद से. For smaller inputs, try to solve it yourself. Once you get that logic, now you have to convert in terms of code. And while converting in terms of code, don't worry about what the complexity is going to be. You write n cube n to the power 4 solutions and then try to optimize it. That's the correct way to approach problem. Solve for the smaller inputs yourself. Once you get the solution, try to write that code without worrying about time complexity. Once you get that code, right, then try to optimize it. Okay, this can be removed. This is not required. I can do it in this way. And then finally you will get the optimal code, which is like best complexity that you can create for that. Okay. Clear? So this should be your approach, which will gradually develop, right? You'll understand this, solving. That's what we are trying to do right now. You're in the gym, right? You're trying to train your brain, not your like body. Once your brain gets trained, you will be like you will start thinking in this way. Okay. Question link. Carpool one के पहले जो solve करा था, this one minimum transform, like okay, this one. Let me paste it also in the GDB. So I'll share this link now. Please paste this in your groups. I don't think. Yeah. So this is. Right. This is the link. Please save it. This is for today's contest discussion. All the question solutions are over here, along with the question links. The question links are also in this sheet. So you can check that. Okay. Please save it. Otherwise, once the meeting ends, this would get deleted. Okay. Any other doubts? Anything else that you want to ask? Okay. So this the question contest that you saw right now. This is going to be the level of your final module test, right? So you can prepare accordingly. You can get your doubts cleared. You can get your doubts addressed, whatever you have, right? And so that you are prepared for this one. Okay. Clear?
So module test का इस level पे होगा sir?
Module test, yes, it's same level.
इसी level का question?
Easy, medium, hard. Yes, that's what I'm expecting. The hard one will not be
Okay.
actually very hard. Medium level kind of thing would be there. Okay, three questions for the module test. So one would be easy, right? So similarly, you saw right here also one was very easy. Then second one would be medium, little bit tricky to figure out. Today's one was like a lot trickier, but we somehow reached that. So for example, I'll say that don't waste your time initially for finding out the optimal solution, because that question, I did it to find out the optimal solution because I knew that there is a order and solution for that. Okay. If you see the constant is like 10 to the power 4 or something, you can go for n square right now. Okay, don't waste your time on questions in exam, because right now we have time. While discussing, we have time. We can take 2 hours to discuss. But while solving in the actual time, like exam, you are given the 1.5 hours, right? So you have to solve it within that. So there you don't have to think too much about time. Your logic should be how solving it. And if it doesn't get accepted, like you get TLE or something, you can optimize it. Okay, that's something you can do. Now the hard ones, try to think for the smaller inputs, right? If there is a part, try to think for the smaller input, how you're trying to solve, and then think of the solution that you will be writing. Okay, most likely it won't be too hard, right? It's going to be easy. Similar to the today's question, it was tricky. I'll not say it is very hard. It should have been medium, right? Not very difficult, because we did questions similar to that, starting from 1 size subarray, 2 size subarray, and something like that. Right? So that you can solve. Okay. Hello, all the best. Hopefully I'll see all of you in module 2. Okay. Thank you everyone. Prepare well for the module test. All the best. Bye bye. Take care. See you.